Something is racing toward our sun right now, and it's unlike anything humanity has ever seen before. At first glance, it looked like a comet, a faint dot of light cutting across the night sky. But the moment astronomers ran the numbers, they realized this wasn't behaving like anything born in our solar system. Instead of drifting along in the predictable whirlpool of planets and asteroids, this object was moving against the current, carving its own path as though it didn't belong here at all. And then came the discovery that changed everything. Its speed, 36 miles every single second. That's fast enough to cross the United States in less time than it takes you to blink. No comet we've ever studied has moved like this. No asteroid we've ever tracked has traveled with such power. This wasn't just another space rock. It was a messenger from beyond, and it was breaking every record we thought was possible. For scientists, the shock wasn't just in the velocity. This object, officially marked as the third confirmed visitor from interstellar space, is larger, brighter, and more active than anything that has ever entered our neighborhood. Imagine a frozen giant forged in the heart of another star system, carrying ice older than Earth itself, suddenly erupting to life under the heat of our sun. For the first time in history, humanity has a front-row seat to a cosmic traveler that may hold clues about how alien worlds form, survive, and even collapse. And here's the part that has sparked headlines around the world. Some experts believe this may not be just a random rock from the void. A Harvard professor has even raised the possibility that what we're seeing could be alien technology, a probe, a vessel, a signal that we're not as alone as we've always believed. The story began quietly, on a night when the skies over Chile's Atacama Desert were as dark as ink. High in the mountains, the Atlas telescope system was scanning the heavens, its robotic eyes sweeping across the southern sky. Its mission was simple: find threat. Designed to catch asteroids that could slam into Earth with catastrophic force, the system had already proven its worth as a silent sentinel, alerting scientists to countless space rocks that might otherwise go unnoticed. But on this night it caught something that wasn't supposed to exist. A tiny dot of light was moving in a way no asteroid or comet ever should. To the casual observer, it was just a speck against a backdrop of countless stars. To the astronomers monitoring the data, it was immediately a mystery that demanded answers. Everything born inside our solar system follows the same general rule. Picture a giant whirlpool, with the sun at its center, and the planets, asteroids and comets swirling in neat predictable arcs, like leaves trapped in a current. That's orbital mechanics, nature's invisible law, ensuring that anything born here stays bound to our star's gravity. But the newcomer spotted that night wasn't following the current. It was cutting against it, carving across the spiral like a swimmer fighting upstream. Its direction alone set it apart from everything we thought we understood. The more researchers traced its path, the more impossible it seemed. Whatever this was, it hadn't been born here. It was a stranger, a visitor from beyond. At first, the team thought there must have been an error. The telescope might have glitched, or the software tracking its movement might have mistaken it for something else. But no. Every follow-up image confirmed the same story. This object wasn't bound to the sun's gravity. It wasn't circling around for another pass like comets usually do. Instead, it was on a one-way trajectory, cutting through our solar system like a stone skipping across a pond. Within hours, whispers spread through the astronomy community. This might be an interstellar visitor, and if that were true, it would make history. The scientists quickly calculated its orbit. What they found only deepened the mystery. Its eccentricity, the number used to describe how stretched or open an orbit is, was off the charts. For context, anything born in our solar system has an eccentricity less than 1. It forms a closed loop, always tied back to the sun. Even Pluto, with its odd and tilted path, still loops back around eventually. But interstellar objects have eccentricities greater than 1, which means they follow open-ended paths that never return. They appear once, sweep past the sun, and then vanish into the black forever. When the number for this object came back, jaws dropped. It scored an eccentricity of 6.2, the highest ever recorded. That meant not only was it interstellar, it was the most unbound, most obviously foreign traveler we had ever seen. To put it simply, this wasn't just a comet drifting in by chance. It was a runaway from somewhere unimaginably far away. The implications sank in quickly. We had been here before, twice. In 2017, astronomers spotted the elongated mystery dubbed Oumuamua, a strange cigar-shaped body that sparked endless debates about its nature. Was it an asteroid, a fragment of a shattered planet, or, as one daring Harvard professor suggested, was it a probe, a relic of alien engineering sent across the galaxy? Then in 2019, Comet Borisov appeared, behaving more like a traditional comet, with a glowing coma and a tail, though still hailing from beyond the sun's grasp. Those discoveries had already rewritten textbooks. Now a third arrival was here, and from the start it seemed even stranger. Bigger, faster, and more dramatic than either of its predecessors, this new wanderer had the scientific world on edge. Telescopes across 6 continents swiveled to focus on it. Every major observatory scrambled to capture its light before it slipped away. Unlike planets or even most comets, these interstellar visitors don't linger. They arrive suddenly, flash through our neighborhood, and are gone in a blink of cosmic time. This object, moving faster than any before, would cross the solar system in under 2 years. Astronomers had mere months to learn everything they could. The race had begun, and the first clue about just how extraordinary this traveler was came from its velocity. Most asteroids cruise along at speeds measured in the thousands of miles per hour. Even comets, often faster, usually travel at rates that, while impressive, are still within the realm of the expected. But this object? 36 miles per second. Imagine standing next to a highway where cars blur past at impossible speeds. Except here, those speeds were astronomical. 36 miles every single second meant it could outpace any spacecraft humanity had ever built, leaving even the fastest probes in its dust. For perspective, you could travel from New York to Los Angeles in less than 2 minutes at that speed. What takes a commercial airliner 6 hours would be completed before you could finish reading this sentence. That kind of velocity isn't just a fun fact. It tells a story. The faster an object moves, the more energy it must have absorbed to reach that speed. To accelerate something the size of a mountain to such a velocity requires an unimaginably violent event. Scientists compared it to forensic detectives analyzing a bullet's trajectory. By reading the speed and direction, they could piece together clues about the cosmic catastrophe that launched it into space. This was no gentle ejection. Something colossal had happened in a distant star system. Maybe a close pass with a giant planet, maybe a violent stellar explosion that flung this object with so much force it escaped not only its home star but any chance of being pulled back by nearby systems. It had been set adrift with a mission written in velocity to wander forever, and wander it did. For millions of years, perhaps even longer, this alien rock had drifted between stars, exposed to the brutal emptiness of interstellar space. Cosmic radiation battered its surface, micrometeorites chipped away at it like sandpaper, and temperatures just a breath above absolute zero froze it into silence. Yet somehow, against all odds, it endured. By the time it reached our solar system, it had survived one of the harshest journeys imaginable, carrying within it secrets of its origin, secrets that scientists now had a fleeting chance to uncover. The excitement built quickly. Observatories scrambled, professional astronomers stayed awake through endless nights, and even amateurs pointed their telescopes toward the intruder. There was a sense of urgency, a recognition that this was a once-in-a-lifetime opportunity. The rarity alone was staggering. In all of human history, across thousands of years of skywatching, only 3 such visitors had ever been confirmed. 3, fewer than the number of people who have walked on the moon. Each discovery was like finding a needle in a galactic haystack. This wasn't just science, it was history unfolding in real time. And yet the most shocking revelations were still to come. What telescopes were about to uncover would not only confirm the object's alien origin, but also challenge our understanding of what interstellar wanderers could be. As the data streamed in and the images sharpened, it became clear that this was no ordinary comet. It was bigger, faster, stranger, and some whispered, possibly something more. The moment astronomers confirmed its speed, the scientific world held its breath. 36 miles every second. The number itself sounded almost absurd, like something out of science fiction. But it was real, verified by independent observatories across the world. To put it in perspective, that's nearly 200 times faster than a bullet leaving the barrel of a rifle. It's faster than the fastest spacecraft humanity has ever launched, faster than the escape velocity of our own solar system, faster than almost anything we had ever measured moving through our cosmic neighborhood. For comparison, Oumuamua, the enigmatic interstellar object spotted in 2017, was traveling at a then record-breaking 16 miles per second. Comet Borisov, the second confirmed visitor from beyond the stars, clocked in around 20 miles per second. Both numbers stunned scientists at the time. But this new arrival was something else entirely. 36 miles per second shattered every record, nearly doubling the speed of its predecessors. Speed in the cosmic sense is not just a number, it's a biography. It's a story written in velocity, a fingerprint of the forces that shaped an object's journey. An asteroid drifting slowly along might have been nudged by gentle gravitational interactions, a comet pulled from the outer reaches of our solar system by the tug of Jupiter. But an object moving this fast? That demanded a history of violence. Only catastrophic encounters could launch a body of this size to such extremes. Close passes with giant planets, gravitational slingshots in binary star systems, or even the aftermath of stellar explosion. Imagine a world torn apart by the death throes of its sun, chunks of ice and rock flung into the abyss with enough force to escape not just their home, but every nearby star's gravity as well. Our mysterious visitor bore the signature of just such a cataclysm. Its speed was proof of a violent birth, and velocity tells us something else too, how far it has come, and how long it has been traveling. At 36 miles per second, this object could cross the distance between stars in just a few million years. That might sound like an eternity, but in the grand scale of the cosmos, it's practically yesterday. If it had been launched 4 million years ago, a blink of geological time, it could have set out from a star system dozens of light years away and reached us in time. The speed suggested freshness, a relatively recent ejection event, as if some distant system had hurled it into space not too long ago. And now it was cutting through our skies like an interstellar time capsule delivered on Cosmic Express. The numbers also revealed another uncomfortable truth. At this velocity, nothing, not even the gravity of our sun, could hold it. No matter how close it came, no matter how much solar energy bathed its surface, it would never stay. It was already moving too fast, already on a hyperbolic trajectory that guaranteed escape. Even if it dove into the sun's corona, the immense gravitational field at the very edge of our star, it would still emerge with enough speed to continue its journey outward, never to return. It was just passing through, and we had one chance to learn from it before it disappeared forever into the darkness. That urgency fueled a frenzy unlike anything the astronomical community had experienced before. Observatory directors around the globe began emergency scheduling sessions, reshuffling entire calendars just to dedicate time to this single object. Telescopes from Chile to Hawaii to the Canary Islands pivoted toward the faint streak of light. Every clear night mattered. Every hour of data captured was a treasure, an irreplaceable glimpse into something humanity might never see again. Some astronomers compared it to a gold rush, except the gold wasn't material wealth, it was knowledge, locked inside an alien traveler that would vanish in months. But speed is more than a curiosity, it's a clue about the universe itself. The way this object sliced through our solar system, the energy it carried, the trajectory it followed, all of it forced scientists to ask deeper questions. How many of these wanderers are out there? How often do they pass through unseen, moving so quickly that they escape detection? If we had spotted 3 in just a few years, could that mean there are thousands more racing silently through the dark? And if that were true, what does it say about the galaxy we live in? Perhaps interstellar space isn't empty at all, but a vast highway filled with cosmic debris, each piece carrying a story of another world. Still, one question loomed above all the rest. Why this speed? If velocity is the imprint of an origin, then what kind of stellar neighborhood had birthed such a monster? Scientists speculated it might have come from the galaxy's thick disk, a region populated by ancient stars that orbit high above and below the galactic plane. These stars are older, poorer in heavy elements, and often more chaotic in their gravitational interactions. In such a turbulent environment, the chances of violent ejections are far higher. A close encounter with a rogue planet, a binary star system flinging objects outward like cosmic slingshots, or the chaos of a collapsing planetary system could have given it the kick that set it on its journey. Its speed wasn't random, it was a message written in momentum, telling us something about the place it once called home. For the public, the velocity captured imaginations in a different way. 36 miles per second wasn't just a statistic, it was something you could almost feel. News anchors compared it to crossing continents in the blink of an eye. Scientists explained it in terms of breaking free from the solar system, a feat no human spacecraft could ever match. And tucked within all those headlines was the whisper of something even more provocative. If nature could fling an object so fast, couldn't technology do the same? If humanity someday dreams of reaching other stars, we'll need to master velocities like this. Was our interstellar visitor then not only a relic of an alien star system, but also a glimpse into our own possible future? In the entire span of human history, across thousands of years of stargazing, chart-making and telescope building, only 3 confirmed objects have ever come to us from beyond our solar system. That fact alone should stop us in our tracks. Think about how vast the night sky is, how endless the flow of comets and asteroids seems when we read about meteor showers or see streaks of light burning across the atmosphere. To our eyes, the heavens are busy. Yet among all that motion, nearly every single object is tethered to the sun, bound to our star's gravity in some loop or cycle, no matter how stretched or irregular. Only 3 times have we found something that broke that rule, something that didn't belong here. This new visitor, racing faster than any before it, is the third and by far the most intriguing. The first was Oumuamua in 2017, and its arrival was almost accidental. Discovered too late for us to capture clear images, we were left with data points that sparked furious debate. It was oddly elongated, its brightness flickering as though it were tumbling through space like a shard of broken glass. Stranger still, its trajectory shifted ever so slightly, as if a subtle push was accelerating it, not enough to scream engines or rockets, but enough to raise eyebrows. Comets can do this when they vent gas as they warm near the sun, but Oumuamua displayed no coma, no tail, no visible sign of outgassing. It left scientists with more questions than answers, and one bold voice, Harvard's Avi Loeb, suggested the possibility of alien technology. He was widely criticized, yet his idea lodged itself in the public imagination. For the first time, the phrase interstellar visitor was paired with whispers of extraterrestrial origin. 2 years later came Comet Borisov, discovered by an amateur astronomer in Crimea. Unlike Oumuamua, this one looked like a classic comet, a glowing nucleus, a long tail of dust and gas streaming out behind it. It behaved more like what astronomers expected, but the chemical analysis revealed subtle differences. Its makeup was similar to comets born in our own solar system, but not identical. It was like tasting a familiar dish made with ingredients grown in another land, recognizable yet foreign. Borisov confirmed that planetary systems beyond our own create icy bodies just like ours, and that they too are sometimes ejected into interstellar space. It reassured scientists who wanted a natural explanation for Oumuamua, showing that interstellar debris could indeed resemble what we already knew. Still, its arrival was another statistical miracle. 2 such objects in just a few years suggested that the galaxy might be far more crowded with wandering messengers than we had ever realized. Now, not long after Borisov's passage comes the third, and if the first was a mystery and the second a reassurance, the third is something altogether more disruptive. Bigger than Oumuamua, faster than Borisov, stranger in almost every measurable way, it seems to combine the best and worst of both worlds. It is bright, easy to track, and spectacular in its display, but it also carries anomalies that make it hard to classify neatly. It is as though the universe decided to give us a case study and a riddle all at once, daring us to interpret what it means. The rarity of these visitors cannot be overstated. For decades, astronomers speculated about them without ever seeing one. Theoretically, if planetary systems around other stars formed in ways similar to ours, there should be countless comets and asteroids tossed outward over billions of years. Gravity slingshots, collisions, and near misses would hurl debris into interstellar space, turning the galaxy into a vast sea of exiles. But theory is not the same as observation. Until Oumuamua appeared, we had no proof that interstellar objects actually passed through our neighborhood. Even then, skeptics wondered if we had simply gotten lucky, catching a once-in-a-century fluke. When Borisov appeared just 2 years later, the idea of luck gave way to a more sobering possibility. Maybe the universe is far more dynamic than we assumed, and we had simply lacked the tools to note it. This new object is the confirmation that those suspicions were correct. 3 sightings in such a short time imply that interstellar wanderers might not be rare at all. They might be constant, arriving every few years, their faint streaks hidden among the millions of rocks we catalogue each month. If that's true, then the night sky is not a sealed dome of familiar orbits, but a porous frontier, with visitors slipping in and out like strangers passing through a crowded city. And each one is a messenger. Each one carries the chemical fingerprints of its birth system, the scars of its journey, the hidden history of planets and stars we may never see. But if abundance is one revelation, uniqueness is another. Because for all the similarities these three visitors share, unbound orbits, extreme speeds, each has been radically different. Oumuamua was long, thin, reflective and eerily quiet. Borisov was dusty, gassy, more like the comets we know, and now this third visitor appears to be larger still, glowing with jets of vapor that mark it as volatile yet enduring. If we had hoped to find a typical interstellar object, something that could be used as a model, we have been disappointed. Instead, each one feels like a distinct character, with its own quirks and mysteries. That diversity is exciting, but also troubling, because it suggests we cannot predict what the next one will look like. There may be no template for an interstellar visitor, only surprises waiting to be uncovered. What makes this all the more staggering is the sheer improbability of catching them at all. The distances involved are incomprehensible, the volumes of space they traverse unimaginably large. It is like standing on a beach and trying to predict which wave will carry a shell to your feet. For one object to cross our tiny corner of the galaxy is remarkable. For three to appear within just a handful of years suggests that either we are living in an unusually busy patch of the cosmos, or that the galaxy is teeming with travelers and we are only now learning how to see them. Either way, the implications reach far beyond astronomy. If interstellar debris is common, then so too are the exchanges of material between star systems. And if fragments of rock and ice can make the journey, why not the building blocks of life? Why not microbes shielded in icy shells, hopping from star to star across the eons? The notion of panspermia, the idea that life might spread across the galaxy via comets, suddenly feels less like science fiction and more like an inevitable consequence of celestial traffic. This is why the third visitor matters so much. It's not just another comet, not just another headline about speed or size. It is a piece of evidence in a larger argument about who we are and where we come from. Every molecule on its surface, every dust grain it sheds as it warms under our sun, is a clue about the chemistry of alien worlds. Studying it is like peeking into a laboratory billions of miles away, one we could never reach by spacecraft, but that has come to us unbidden. And unlike the first two, this one offers us a clearer, longer view. It is larger, easier to track, giving us a rare gift: time. Not much, but more than we had before. Enough, perhaps, to capture spectra, analyze its outgassing, and build a picture of the place it once called home. The knowledge that this is only the third in recorded history adds weight to every observation, every image taken by Hubble, every data point captured by ground-based observatories becomes part of a legacy that may be studied for centuries. People centuries from now may look back on these nights as the beginning of a new era in astronomy, the moment when interstellar research moved from theory to observation. The first was a whisper, the second was a confirmation, but the third is a declaration. We live in a galaxy alive with motion, and we are not isolated within it. And yet, even as scientists celebrate, they cannot escape a lingering unease. If three such objects have appeared in quick succession, then how many passed unnoticed in the centuries before we had telescopes powerful enough to see them? How many have slipped by in the gaps between our surveys? And what if, among those countless unobserved wanderers, one carried something more than dust and ice? What if one of them was not just a messenger of geology, but a messenger of intent? That possibility, however remote, is enough to keep even the most rational astronomer awake at night. The third visitor, then, is not just a discovery, it is a reminder that the universe is not static, that it does not sit quietly while we point our telescopes outward. It is dynamic, unpredictable, alive with movement. And in that movement lies both knowledge and mystery. Every passing object is an invitation to learn, but also a warning that the cosmos is far less predictable than we once believed. Of course, with that thought came the speculation scientists hate, but the public loves. What if it wasn't natural at all? After all, Oumuamua's strange acceleration had already ignited debates about alien technology. Could this new, faster, larger visitor also carry the same possibility? Its trajectory was natural. Yes. Its chemistry, as far as early readings suggested, was comet-like. But its speed, so extreme, so improbable, was hard to ignore. If we were to send a probe across the galaxy, Wouldn't it look just like this? A cold, reflective object, moving faster than anything else, slipping through star systems on a path no gravity could contain. The idea hovered at the edges of scientific discourse, unspoken in most journals, but present in quiet conversations. Perhaps this wasn't just a comet, perhaps it was something built. Whether natural or not, the speed made one thing certain: time was short. The object wasn't going to linger. It would flash through our solar system and vanish into the void, carrying with it answers we might never recover. Every second counted, every measurement mattered, and as the data poured in, scientists realized that velocity was only the beginning. This visitor had more surprises to reveal. Its size, its chemistry, its behavior under the sun, and each revelation would be stranger than the last. When the first detailed calculations came in, astronomers were stunned. Not only was this object moving faster than any natural visitor they had ever measured, it was also much larger than anything expected from beyond our solar system. Early estimates suggested that it wasn't the size of a football field like Oumuamua nor even a modest mountain like Borisov, but something far more imposing. This was an interstellar behemoth stretching for miles across, large enough to rival a small city. Suddenly, this wasn't just a speck of dust or an odd shard drifting in from another star. It was a colossal traveler, built to survive the unrelenting emptiness of deep space, and it was sweeping through our neighborhood like a ghost ship from the stars. Size matters in astronomy, and not just for the obvious reasons. A larger body means greater gravitational binding, a stronger ability to resist breaking apart under the stresses of cosmic travel. Small rocks and shards of ice can be shredded by radiation, cracked by micrometeorites, or boiled away during close passes to stars. But something several miles wide is built to endure. It can take the punishment of billions of years drifting through radiation storms and interstellar dust. It can be scarred, battered, and pitted, yet still survive mostly intact. That's why the sheer scale of this object was so electrifying. It wasn't just a fleeting piece of rubble, it was a survivor, a true veteran of the galaxy, carrying within it pristine material from a world we would otherwise never touch. The Hubble Space Telescope was quickly trained on the object, and though it appeared faint against the backdrop of stars, its dimensions became clearer with each observation. From Earth it shimmered like a teardrop of light, its nucleus glowing faintly, a husk of ancient ice awakening under the warmth of the sun. Unlike the thin, elongated profile of Oumuamua, this one was bulky and rounded, massive in every direction. At its widest, estimates suggested it stretched several miles across, big enough that, if it were to strike Earth, it would end civilization in an instant. Of course, its trajectory posed no danger to her, but imagining such power barreling through our skies was enough to send a chill down the spine of anyone who understood the consequence. The sheer size also meant it was easier to study, easier to track across nights of observation. Where Oumuamua slipped away so quickly that scientists scrambled to capture even a handful of data, this giant glowed bright enough that even smaller telescopes could follow its path. Amateur astronomers across the globe joined in, sending their images and measurements to professional teams. It became a rare kind of scientific event, one that united not only nations but also professionals and enthusiasts in a single pursuit: understanding what exactly this alien visitor was made of. As the data came in, the details painted a picture of an object unlike anything in our solar system. Its surface reflected light strangely, suggesting a crust that was both rugged and unusually dark, as though it had been charred by radiation during its long journey. Bursts of brightness hinted at volatile ices boiling away in sudden jets, releasing clouds of gas and dust that stretched behind it in faint streaks. These outgassing events were dramatic, much stronger than those typically seen in comets from our own system. That made sense. A body this massive would carry reserves of frozen gases buried deep within, untouched for millions of years until the sun's rays finally reached them. When those reserves vented into space, they did so with power. Each eruption was like a volcanic blast, throwing alien material across thousands of miles. This is where the enormity of the object became not just a fact of measurement, but a scientific opportunity. The more material it shed, the more light it emitted, and the more easily we could analyze it. Telescopes with spectrographs dissected the light into colors, reading the chemical fingerprints hidden within. And what they found was astonishing. The gases contained not only water vapor, carbon monoxide, and other familiar molecules, but also complex organic compounds that hinted at the chemistry of alien worlds. These organics weren't unique to Earth. They weren't unique to our solar system. They were universal building blocks, created in environments billions of miles away, now wafting through our sky. Imagine standing on Earth and breathing air that once belonged to another star system. That's what studying this object felt like for scientists. Each molecule it vented had been forged in the crucible of a sun we could not see, born on a world we would never visit, only to drift for millions of years before releasing its secrets in our cosmic backyard. That was the gift its size granted us. Enough mass to survive the journey, enough energy to erupt dramatically, enough chemistry to reveal truths no smaller fragment could hold. But the revelations didn't stop there. Its mass also suggested a remarkable history. To form something several miles wide requires a stable, resource-rich planetary system. Tiny shards can be the product of collisions, fragments chipped off in cosmic accidents. But giants are different. They speak of abundance, of planets and moons colliding and reforming, of disks of ice and dust thick enough to assemble mountains. This object then was a relic of a thriving system, one robust enough to birth such titans, one violent enough to eject them outward, and one old enough that at least some of its survivors had now wandered into our skies. In other words, this was proof that the drama of creation and destruction plays out far beyond our own corner of space. Other solar systems, other suns, have their own histories of chaos and violence, and their debris sometimes finds its way to Earth. The emotional impact of that realization is hard to overstate. For centuries, humanity has gazed upward and wondered what other worlds exist beyond the reach of our telescopes. We've built probes to fly past distant planets, sent satellites to the edges of our system, and dreamed of journeys to the stars. Yet here was a world coming to us, carrying in its body the chemistry of another sun, the scars of another history, the frozen memory of a place we could not reach. And it wasn't a fragile scrap. It was enormous, enduring, a survivor large enough to defy destruction and deliver its message intact. Of course, its size also carried a darker implication. Interstellar objects of this scale may not be common, but if even 1 in 10,000 follows a path that intersects with Earth, the consequences could be catastrophic. Scientists reassured the public that this particular visitor posed no threat. Its orbit would take it past the Sun and back out into interstellar space without crossing Earth's path. But the thought lingered nonetheless. What if, one day, a city-sized object from beyond the stars did set its sights on us? Would we even have time to respond? Could we? The universe is filled with unimaginable forces, and sometimes it takes a visitor like this to remind us of our fragility. Yet fear was not the dominant reaction. Awe was. Scientists who spent their lives studying distant galaxies suddenly found themselves marveling at a single rock, because it wasn't just a rock, it was a message about survival, about scale, about the resilience of matter itself. In its colossal body, scarred yet intact, it told the story of a galaxy filled with violence and creation, and of the astonishing ability of nature to preserve fragments of those stories for us to read. As the object drew closer to the warmth of our sun, its frozen shell began to speak. At first, the glow seemed ordinary, the way comets from our own backyard brighten as ice vaporizes into space. But when astronomers trained their most sensitive instruments on the faint ghostly cloud trailing behind it, they realized they were watching something entirely unprecedented. The gases and dust carried within that haze were not only familiar in part, but also alien in detail, fingerprints of chemistry that no telescope had ever recorded before. The key was spectroscopy, the art of turning light into language. Every atom, every molecule absorbs and emits light in its own unique way, creating a barcode of sorts. When sunlight passed through the vaporizing halo around the object, it carried with it clues to the ingredients being released. By breaking that light into its spectrum, scientists could read those clues line by line, uncovering what the visitor was made of. And what they found was nothing short of breathtaking. There were traces of water vapor, yes, something expected, because ice is common throughout the galaxy. There were carbon compounds too, the backbone of organic chemistry. But alongside these familiar elements were subtle variations, ratios of isotopes that didn't match anything formed in our own solar system, molecules slightly altered by the conditions of an entirely different star. It was as though someone had handed us a recipe from a kitchen in another country. The ingredients were recognizable, but the flavor was unmistakably foreign. Each molecule carried within it the signature of a birthplace light years away. Among the most startling finds were complex organics, the kind that form the scaffolding of life as we know it. Not life itself, nothing alive was drifting in that cloud, but the raw components from which life could one day emerge, chains of carbon, hints of amino-like structures, building blocks that under the right conditions could become the seeds of biology. It was a sobering reminder that chemistry is universal. What happens on Earth is not unique to Earth. The same experiments are running on countless worlds, countless comets, countless fragments of icy debris scattered across the galaxy. The universe, it seemed, was endlessly generous with the ingredients of life. And yet, there was more. Some molecules appeared scarred, their structures twisted by long exposure to cosmic radiation. Others bore the marks of ancient stellar nurseries, forged under pressures and energies Earth had never known. These were not simply frozen relics. They were records, history books etched at the molecular level, telling us about the environments this body had passed through. Some of the compounds hinted at high-temperature formation, perhaps near the heart of a young star. Others spoke of freezing low-energy conditions, far out in the shadowed edges of a planetary system. It was as if the object had carried within it layers of memory, snapshots of different worlds it had touched or been shaped by, preserved for millions of years in its icy vault. This is why scientists began to describe it as carrying a kind of DNA. Not literal genetic material, of course, but a chemical code that mapped the history of an alien star system. Every line of the spectrum was like a gene, every molecule like a strand of information. By reading it, we were decoding the biography of a world we would never see. And for the first time in history, we weren't just speculating about what other systems might look like. We were holding the evidence in our telescopes, watching it sublimate into our sky. The implications stretched far beyond chemistry. If molecules could survive the journey across light years of hostile emptiness, then so too could seeds of biology. Even the skeptics of panspermia, the idea that life spreads from star to star, on comets, had to pause. Here was proof that fragile compounds could make the crossing intact. Here was proof that the universe doesn't sterilize everything it touches. On the contrary, it preserves and delivers. If this rock had instead slammed into a planet, instead of passing by, it would have deposited its alien ingredients directly into the soil, into the oceans, into the very building blocks of life. Suddenly, the idea that Earth's first sparks of biology might have been seeded by interstellar messengers didn't sound like fantasy. It sounded like probability. And yet, the mysteries deepened. Some of the detected compounds were unfamiliar, their spectral lines unlike anything catalogued in our databases. At first, some astronomers suspected noise or instrument error, but repeated measurements confirmed them. These were molecules that had formed under conditions we hadn't seen, perhaps involving pressures, temperatures, or stellar chemistries unique to its birth environment. To the chemists, this was both thrilling and unnerving. It meant that the galaxy holds chemical pathways we haven't yet imagined, possibilities of matter that could give rise to forms of life completely unlike our own. It suggested that biology, if it exists elsewhere, might not only resemble us, but might also emerge in ways we cannot predict. The alien chemistry also had a practical effect. The dust grains released in the jets of vapor began to drift into interplanetary space, leaving trails that spacecraft could, in theory, fly through. Some scientists dreamed aloud of capturing those grains with instruments like those used in NASA's Stardust mission, which once collected comet dust and returned it to Earth. The idea was tantalizing. What if we could one day catch pieces of alien star systems not just with telescopes but in our hands? What if we could study in the lab, under microscopes, the literal dust of another world? With missions like ESA's Comet Interceptor on the horizon, the dream didn't seem impossible. The chemistry being revealed now was the first taste of that future, a preview of what we might discover when we finally meet one of these travelers up close. Of course, not everyone was satisfied with purely natural explanations. The moment alien chemistry was announced, the inevitable speculation followed. If this object carried such complex compounds, could it also be evidence of design? Some pointed to the bizarre anomalies of Oumuamua, its acceleration, its reflective surface, and wondered aloud whether this new visitor might hold similar secrets. Could these organics, they asked, be the result of artificial processing, byproducts of a technology beyond our comprehension? The mainstream scientific community dismissed the idea, focusing on natural processes, but the seed of suspicion was planted. And for the public, the story only grew more tantalizing. What if what we were calling chemistry was in fact evidence of something constructed, something intentional? The truth for now remains in the molecules. Each eruption of gas carries a message across space, a whisper from a world that died long before we existed, a hint of chemistry that once thrived under another sun. Though we may never visit that place, never see the planets or stars it came from, we can at least read the words it left behind in the only language it speaks. The patterns of light, refracted through the void. Even as scientists raced to catalogue every molecule before the object vanished, they knew the clock was ticking. It would only pass close enough to study for a few months, maybe a year, then it would be gone. Its alien chemistry fading back into interstellar silence. What we learned in that time would be all we had until the next visitor arrived. But in those fleeting months, we were given something extraordinary. Proof that the galaxy is not silent. Proof that alien systems leave their signatures in matter. Proof that we are not isolated in our chemistry or our possibilities. And as those truths sank in, the object continued on its path, glowing brighter, venting more of its secrets, drawing humanity into a story far larger than itself. A story written in ice, in dust, in light, and carried across the stars on a vessel the size of a city. From the moment astronomers plotted the object's path, a strange unease began to creep into the conversation. On paper, its trajectory was perfectly natural, a hyperbolic orbit consistent with something unbound to the sun. But when you looked closer, when you ran the numbers again and again, the perfection of it began to feel uncanny. It wasn't just that the object was fast, it was that it was moving in a way that seemed almost choreographed, as though some hidden hand had written its route across the sky long before we ever noticed it. Hyperbolic paths are rare but not unheard of. Comets can sometimes be nudged into them by encounters with giant planets, their orbits stretched until they no longer return, but the overwhelming majority of comets we track remain tethered, bound by the sun's pull. Only a handful slip the leash. This visitor, though, was never tethered to begin with. It came in already free, already on a course that no gravity in our system could tame. Its path cut cleanly through the solar plane, slipping past the orbits of planets like an intruder who knew exactly where to walk without being stopped. Jupiter's massive pull didn't tug it noticeably. Saturn's influence left no mark. It passed by the inner planets on a route so precise that some scientists joked it was like threading a cosmic needle. The strangeness wasn't only in the geometry, it was also in the timing. The object approached the sun in such a way that it gave us maximum visibility, dipping close enough to warm and reveal its chemistry, but not so close that it disintegrated. It presented itself like a specimen under a microscope, large enough to see, bright enough to study, cooperative enough to stay intact, and fast enough to remind us we wouldn't have long. If this was a coincidence, it was an astonishing one. If it wasn't, then the implications stretched into territory few dared to speak aloud. Astronomers by training are cautious people. They deal in probabilities, in statistical models, in cautious language that avoids sensationalism. So when some of them began to whisper that the trajectory seemed too perfect, it wasn't the kind of claim tossed around lightly. It was the sort of statement that suggested an unease at the edges of their understanding. The parallels to Oumuamua were impossible to ignore. That earlier interstellar traveller had shown a mysterious acceleration no one could quite explain. This one, though larger and more classically comet-like, carried its own puzzle, a course that seemed engineered for observation. Could it be a coincidence that two of the only 3 interstellar visitors we've ever found both carried anomaly? Or was this simply the bias of limited data, the illusion of pattern in a small sample size? The public, of course, latched onto the more provocative interpretation. Headlines declared it a cosmic probe, a messenger from another intelligence cruising past our system. Social media filled with animations of its path, users marveling at how smoothly it slipped in and out of our neighborhood. Some commentators went further, suggesting it wasn't just passing through but scanning us, observing us in ways we couldn't detect. The idea of a silent alien observer sparked both fascination and fear. While most scientists rolled their eyes at the speculation, a few could not help but wonder in private whether the unease they felt at its precision was justified. Because the truth is that trajectories do tell stories. A comet's orbit reflects its past, where it was born, what forces have acted on it, what encounters have shaped its path. A hyperbolic course implies exile, an object kicked from its home and destined to wander forever. But this visitor's path didn't look chaotic. It wasn't tumbling in wildly from some random angle. It was smooth, direct, and purposeful. It was the difference between stumbling into a room and walking into it with intent. Some tried to explain it through natural mechanisms. Perhaps it had been ejected from a binary star system, where gravitational slingshots are common and precise. Perhaps its size made its orbit more resistant to perturbations, allowing it to glide smoothly rather than wobble under the influence of passing stars. Perhaps we were simply overinterpreting, projecting intention onto coincidence. And yet, no explanation fully erased the strangeness. No calculation could quite shake the feeling that we were watching something too well behaved. The deeper scientists studied, the more the unease grew. For instance, its approach vector where it seemed to come from was oddly unremarkable. It wasn't linked to any particular nearby star system we knew. It appeared to come from the general direction of the galactic plane, a crowded region, yes, but not one with an obvious birthplace. That anonymity was itself strange. Objects ejected from known systems usually carried directional fingerprints. This one arrived as though from nowhere, slipping into our skies like a stranger whose identity could not be traced. The perfection of its exit was equally unsettling. After its closest pass to the Sun, its path swung outward in a clean arc, leaving the solar system behind without so much as a wobble. No planet tugged it off course. No jets of outgassing were strong enough to alter its route in a measurable way. It left as smoothly as it came, as though on rails laid out through the void. For something so volatile, shedding jets of gas and dust, such steadiness was unusual. Even Borisov had shown slight deviations as it vented. This one did not. It seemed to know exactly where it was going, and nothing, not even the Sun itself, would alter its direction. The more data came in, the more polarized the discussion became. The mainstream held firm. Natural explanations must exist, even if we hadn't yet found them. But on the fringes, scientists like Avi Loeb gained renewed attention. If we were to send probes to other star systems, he argued, they would look just like this. They would be icy, reflective, self-stabilizing, moving on trajectories that allowed them to slingshot around stars without being captured. The resemblance was uncanny, and though most dismissed the theory, it lingered like a shadow. What if we were not just watching a rock, but watching a relic of intelligence? Even for those who resisted that leap, the sense of choreography was undeniable. The trajectory seemed to serve us as much as itself, giving us a fleeting but vivid opportunity to witness an interstellar traveler up close. It reminded scientists of a truth often forgotten, that the universe is not arranged for our convenience, and yet sometimes improbabilities align in ways that feel like intention. Whether this object's path was the product of physics or something more, it had delivered itself to us in the most extraordinary way. And as it glided away, leaving us with more questions than answers, one thought persisted. If this was coincidence, then the universe has a strange sense of timing. And if it wasn't, then we may have just glimpsed the first silent signal that we are not alone. The announcement of the object's discovery sent a ripple through the scientific community, but as the details emerged, its speed, its size, its chemistry, and its flawless trajectory, the ripple became a tidal wave. Every observatory that could be aimed at it was aimed. Time on major telescopes, normally scheduled months or even years in advance, was suddenly reshuffled in emergency sessions. It didn't matter whether the instruments were designed for distant galaxies, exoplanets, or dying stars. Everyone wanted a piece of this interstellar interloper before it vanished. In those first days, it felt like a gold rush, not for wealth, but for data. What made the frenzy so intense was the awareness that this was a once-in-a-lifetime chance. For all of human history, only 3 confirmed interstellar visitors had ever been seen. 2 had already slipped away. This one, larger and brighter, was the most generous of them all. But its generosity came with a clock. At 36 miles per second, time was an unforgiving enemy. Scientists knew they had only months before it became too faint, before it drifted back into the abyss and left them with nothing but scraps of data and unanswered questions. That urgency sharpened every discussion, every decision, every late-night observation. Collaboration bloomed in ways rarely seen in the competitive world of research. Teams across continents shared raw data almost in real time. Astronomers in Chile relayed spectra to colleagues in Hawaii before dawn. Observers in the Canary Islands synchronized with NASA facilities, ensuring there were no gaps in coverage as the object crossed the sky. For a brief moment, the boundaries of nationality, Funding and prestige seemed to dissolve under the sheer enormity of the opportunity. It was not about being first. It was about learning as much as possible before the curtain fell. And yet, beneath the collaboration, tensions simmered. The more data poured in, the more difficult it became to interpret. Some measurements suggested the object's surface was unusually reflective. Others hinted at patches of extreme darkness. Outgassing events seemed too strong for its distance from the sun, then inexplicably weakened when closer in. Some teams detected strange organic compounds, while others questioned whether their instruments were picking up noise. The picture refused to settle into something clean, something everyone could agree on. Instead, the object seemed to mock certainty, offering just enough consistency to prevent chaos, but enough anomalies to ensure no single narrative could dominate. That ambiguity fueled debate, and nowhere was the debate louder than in the question of origin. To most astronomers, the answer was simple. This was natural, an ejected fragment from another star system, remarkable only because we happened to catch it. To them, the challenge was not explaining why it existed, but explaining the details of its behavior, why its chemistry looked slightly unusual, why its path seemed so unperturbed, why its speed was so extreme. Those were puzzles to solve within the framework of known physics, not excuses to leap into extraordinary claims. But others were less willing to dismiss the extraordinary. The ghost of Oumuamua hung over every discussion. That earlier visitor had displayed unexplained acceleration, sparking Avi Loeb and a handful of others to propose it might be artificial. Most scientists had scoffed, citing natural explanations, but the media had devoured the idea, and the public remembered. Now, as a second anomalous interstellar object appeared, the question resurfaced with renewed force. Was this too something built? Could it be a probe, a fragment of alien technology drifting silently past our system? The debates were fierce. At conferences, papers were presented in heated sessions where applause and groans sometimes overlapped. Peer reviewers demanded cautious phrasing, yet journalists pressed for bold quotes. Some scientists bristled at the attention given to speculative theories, arguing that they undermined the credibility of astronomy. Others countered that ignoring anomalies was itself unscientific, that true science required entertaining all possibilities, no matter how uncomfortable. The tension between conservatism and imagination, between defending credibility and embracing wonder, defined every conversation. Meanwhile, the public followed every twist and turn with fascination. Headlines screamed of alien visitors, while op-eds urged restraint. Popular science channels broke down the numbers for audiences hungry to understand. Social media buzzed with animated orbits and simulated flybys. For many, this was the first time astronomy felt alive, dramatic, urgent. No longer was it about distant galaxies or abstract physics. It was about something here now, cutting through our skies at impossible speed, carrying secrets from the stars. And in the middle of the frenzy, there was a sobering realization. We were not ready. Our instruments, though powerful, were built for other purposes. We could study stars thousands of light-years away, but struggled to capture sharp images of something passing right through our solar system. We could detect molecules in exoplanet atmospheres light-years distant, yet fumbled to pin down the exact composition of a comet within our own neighborhood. The object exposed the gaps in our preparedness, gaps born of the assumption that interstellar visitors were rare enough to ignore. Now, with 3 discovered in just a few years, that assumption had crumbled, and the inadequacy of our tools was on full display. This spurred calls for change. Voices within the community began pushing for dedicated interstellar observatories, telescopes and instruments designed specifically to catch and study such objects. Some even proposed rapid response spacecraft that could be launched on short notice to intercept a visitor, capturing images and samples before it vanished. The idea seemed ambitious, but as the debates raged, one truth became clear. If these objects were more common than we thought, then sooner or later one would pass close enough to be intercepted. The frenzy surrounding this discovery might be chaotic, but it was also the seed of a new era in astronomy. The excitement wasn't limited to scientists. Philosophers, theologians, and writers weighed in, each interpreting the discovery through their own lens. Some saw it as a reminder of humanity's smallness, proof that the galaxy is alive with processes beyond our control. Others viewed it as a promise, evidence that we are part of a larger story, connected by matter and chemistry to distant stars. And of course, for those inclined to see the hand of intelligence in the cosmos, it was a signal, a whisper that we were not alone. The debate spilled far beyond the observatories and into the culture at large, becoming part of the zeitgeist in a way no comet or asteroid had managed in decades. All the while, the object itself continued on its path, indifferent to the chaos it left behind. It glowed, it vented, it hurtled forward at impossible speed, shedding dust and molecules like breadcrumbs for us to chase. Each night it crept a little farther across the sky, a little dimmer, a little harder to study. The frenzy reached its peak even as the subject of it began to fade, a cruel irony that left scientists both exhilarated and frustrated. They had learned so much, and yet, compared to what they wanted to know, it was almost nothing. In the end, the frenzy revealed more about us than about the object. It showed our hunger for knowledge, our impatience with mystery, our tendency to argue when certainty is elusive, and our willingness to speculate when imagination is irresistible. It exposed the fault lines between caution and daring, between data and wonder, between what we know and what we dream. And in those fault lines, humanity's character was laid bare. We are creatures who cannot look at the sky without asking who we are. We are creatures who see a rock from another star and wonder if it is more than a rock. We are creatures who, in the face of fleeting opportunity, will argue and fight and collaborate and dream, all because we cannot bear to let mystery pass unexamined. And so, as the object dwindled into the distance, the frenzy began to subside, leaving behind papers, data archives, and unanswered questions. But it also left behind something else, a shift in perspective. We had seen 3 such visitors in just a handful of years. There would be more. The next frenzy would come sooner than we once believed. And maybe, just maybe, next time we would be ready. The moment the first press release hit the wires, the object leapt from the pages of technical journals into the bloodstream of global media. Overnight, what had been a cautious, jargon-heavy discovery became a headline machine. City-sized visitor from another star, one paper declared. Is this the proof we're not alone? Asked another. Television networks filled airtime with animated orbits and speculative graphics of alien spacecraft disguised as comets. Social media platforms turned the story viral within hours, hashtags springing up as millions of people shared the idea that something not of this solar system was racing past our sun. The scientists had hoped for public interest, but few were prepared for the storm of attention that followed. The fascination was partly because of timing. Humanity was already living in an age of uncertainty, with new crises and challenges crowding the headlines each day. Against that backdrop, the story of a visitor from beyond offered something both unsettling and exhilarating, a chance to look up from our terrestrial struggles and imagine ourselves as part of something larger. It was escapism, but it was also confrontation. If a fragment of another world could cross our sky, then perhaps our place in the universe was not as solitary as we once believed. The public latched onto that duality, oscillating between wonder and fear, between curiosity and dread. News outlets quickly realized that framing mattered. Some leaned into the scientific angle, explaining the physics of hyperbolic orbits and the chemistry of organic molecules. Others played up the mystery, emphasizing the perfect trajectory and repeating quotes about alien probes. The differences didn't matter. The effect was the same. Ratings spiked, clicks soared, and the visitor became the most talked-about celestial object since Halley's Comet, perhaps even surpassing it. For weeks it dominated not only science sections but front pages, late-night comedy and talk shows. Documentary crews scrambled to produce specials. Within days, streaming services announced fast-tracked projects with titles like Messengers from the Stars and Alien Visitor: The Truth Behind the Hype. Publishers rushed editors to assemble books, while podcasts devoted hours of airtime to speculation. The object wasn't just an astronomical phenomenon, it was a cultural one, spilling into art, literature, and popular imagination. Musicians released songs referencing the interstellar traveler. Fashion brands launched limited collections with comet-inspired designs. Even video games announced downloadable content where players could chase alien rocks across simulated galaxies. But as fascination grew, so too did polarization. For every article presenting careful science, there were 10 that leaned towards sensationalism. Pseudoscience flourished, with YouTube channels declaring the object a disguised mothership and conspiracy sites claiming governments already knew its true nature, but were hiding it. Some commentators insisted it was an omen, tying it to prophecies and ancient myths. Others saw it as proof of a galactic community waiting for humanity to evolve. The internet magnified these voices, And soon the story wasn't just about what scientists could measure, but about what ordinary people imagined. Governments, sensing the wave of public interest, made cautious statements. NASA reassured the world that the visitor posed no threat to Earth, emphasizing its clean trajectory out of the solar system. The European Space Agency echoed the sentiment, while smaller national observatories released updates to show they too were involved in tracking. But the calm tone did little to quiet speculation. In fact, it sometimes backfired. The more officials insisted there was nothing unusual, the more some suspected they were hiding something. In the court of public opinion, reassurance was taken as confirmation of conspiracy. The obsession bled into everyday life. Teachers used the story in classrooms to inspire lessons on astronomy. Parents took children outside to point at the faint streak of light, telling them they were witnessing history. Amateur astronomers shared images online, proud to be part of something that connected backyard telescopes with billion-dollar observatories. In those moments, the line between expert and layperson blurred. Everyone, no matter their background, could feel the awe of watching an alien traveler pass overhead. Yet the media machine thrived on conflict as much as wonder. Panel discussions pitted scientists against ufologists, skeptics against believers. Every minor anomaly in the data was inflated into a talking point. When one research group suggested unusual organic compounds, headlines screamed, "Alien chemistry." When another noted the steadiness of the trajectory, the phrase "impossible path" began trending. It didn't matter that most anomalies had reasonable explanation. In the race for attention, ambiguity was currency, and mystery was gold. This dynamic created friction with the scientific community. Many astronomers felt misrepresented, their cautious words twisted into sensational claims. Some refused to speak to reporters altogether. Frustrated by the distortion, others leaned into the spotlight, seizing the chance to draw attention to their work even if it meant tolerating exaggeration. The divide was stark. Those who saw media frenzy as a distraction, and those who saw it as an opportunity. Behind closed doors, debates raged about whether courting public imagination was worth the cost of credibility. And yet, despite the frustrations, something extraordinary was happening. For the first time in decades, the world was united in wonder about the cosmos. The visitor became a rare point of common ground across cultures and borders. In a time when divisions seemed insurmountable, millions of people looked at the same sky and asked the same questions. Who else is out there? How many of these travelers exist? What do they carry with them? The debates, even the wild speculations, were proof of a shared human instinct, the need to connect our small lives with something infinite. Artists captured the mood with haunting imagery. Murals of glowing city-sized comets streaking across night skies, sculptures of frozen shards suspended in galleries, films that imagined humanity's first meeting with alien messengers. The object became not just a scientific discovery, but a symbol, a mirror reflecting our hopes, fears, and imagination. For some, it was a reminder of fragility, that a rock from beyond could one day end life as we know it. For others, it was a beacon of possibility, proof that the galaxy is alive with stories waiting to be told. Meanwhile, the media cycle churned on, feeding on every update. Each new observation was treated as breaking news. When Hubble captured sharper images, the pictures trended worldwide. When researchers released papers about isotopic ratios, blogs framed them as evidence of alien DNA. Even silence became a story. When a week passed without major updates, speculation flared about whether scientists were hiding discoveries. It became a feedback loop, where public hunger drove coverage, and coverage drove more hunger. Inevitably, fatigue set in. After weeks of saturation, the story began to wane. Other headlines took over, new crises demanded attention, and the visitor slowly slipped from the front pages. But unlike most viral phenomena, it didn't vanish completely. The fascination lingered, embedded in culture. The object appeared in novels, in memes, in conversations about humanity's place in the universe. It left a residue of wonder, a reminder that something from beyond had come and gone, leaving us changed. And for scientists, the media frenzy had a paradoxical effect. It was frustrating, even chaotic, but it also secured funding, inspired students, and galvanized interest in projects that might have otherwise languished. Politicians, sensing public enthusiasm, began to support proposals for faster response missions, new telescopes, and broader surveys of the sky. The frenzy, for all its distortions, had achieved something profound. It had reminded the world that looking up matters. As the object faded into darkness invisible to all but the most powerful instruments, the cultural obsession it sparked lived on. In 1,000 different ways, in classrooms, in art studios, in government offices, it had left its mark. It had shown that science and society are not separate, that discovery is not confined to laboratories, and that sometimes a rock from another star can capture the collective imagination of an entire planet. As the visitor carved its silent arc across the solar system, the awe it inspired gradually gave way to a more primal reaction: fear. For every headline celebrating the discovery, there was another warning that it might be a threat. The very qualities that made it extraordinary, its colossal size, its alien chemistry, its impossible speed, were also the ingredients of a nightmare. People began to imagine what would happen if its path shifted even slightly, if gravity tugged it toward Earth, if its flawless trajectory concealed a hidden danger. The thought that something the size of a city, moving faster than anything we had ever measured, could one day collide with our fragile planet was enough to set imaginations on fire. Scientists insisted there was no risk. They explained the math in calm, measured tones. The orbit was clear, the angles were solid. There was no chance it would cross Earth's path. But human imagination is not bound by orbital mechanics. To many, reassurance felt hollow, especially in a world where trust in authority was already fragile. And so, conspiracy forums lit up with theories. Some claimed governments were lying, hiding the truth to prevent panic. Others pointed to ancient prophecies, twisting the object into the latest candidate for an end times omen. Hashtags like Doom Comet and Alien Harbinger began to trend, and videos showing fake impact simulations racked up millions of views. The fear seeped into daily life. Some people stocked up on supplies, treating the visitor like a cosmic countdown clock. Survivalist forums buzzed with talk of bunkers and underground shelters. Religious leaders in some communities declared it a divine warning, a sign that judgment was near. Even in places where rational voices tried to calm the panic, whispers persisted. The sheer size of the object was too much to ignore. Everyone knew that if it hit Earth, the result would be nothing short of extinction. And so, even if the probability was zero, the possibility was all anyone could think about. Television networks exploited the tension, producing special reports that balanced scientific explanations with dramatic visuals of planetary destruction. Computer-generated firestorms engulfed continents on screens, with solemn narrators intoning what might happen if the visitor's course were even slightly altered. The images were impossible to shake. Children had nightmares of burning skies. Adults found themselves staring upward, half expecting to see the fiery tale of doom. Even those who trusted the science couldn't help but imagine the what-if. Because deep down, humanity knows how fragile it is, how often history has been shaped by rocks falling from the sky. The dinosaurs never saw theirs coming. Who could say with certainty that we would fare any better? The fears weren't only about physical destruction. Some imagined darker, stranger scenarios. What if the object wasn't natural at all? What if it was a vessel, and its silence was deliberate? The idea of an alien probe wasn't new, but combined with the visitor's scale and speed, it took on ominous undertones. Some speculated it might be scanning us, gathering data for a civilization that viewed us the way we view ants. Others feared it was a harbinger, a scout sent ahead of something larger, something designed not to observe but to conquer. Science fiction novels that once seemed fanciful suddenly felt uncomfortably relevant, and every unexplained anomaly in the data fed the paranoia. Governments had to respond, not just to the scientific challenge of studying the visitor, but to the social challenge of calming fear. Press conferences emphasized again and again that the orbit was safe, that the object would pass without harm. But these reassurances often backfired. The more officials insisted there was no threat, the more some people believed there must be one. After all, hadn't governments downplayed dangers before? Hadn't experts been wrong in the past? And so the doomsday narrative continued to grow, fueled not by facts but by the human need to wrestle with mortality. Even within the scientific community, private conversations revealed an undercurrent of unease. Not that anyone believed the object posed a risk of collision, but the sheer reminder of scale was sobering. If objects like this exist in large numbers, and 3 had already appeared in just a few years, then the possibility of a future impact, however distant, could not be ignored. A body this size would dwarf the asteroid that wiped out the dinosaurs. It would vaporize cities, ignite global firestorms, and plunge the Earth into darkness for decades. The visitor itself might not be the end, but it was a stark reminder that the universe is not gentle and that Earth is not immune. Doomsday culture flourished. Online influencers capitalized on the fear, selling survival kits and impact insurance. Some claimed to have inside knowledge of government evacuation plans. Others sold tickets to bunkers that didn't exist. The line between genuine fear and opportunistic exploitation blurred, and for many it was impossible to tell where truth ended and manipulation began. The visitor became not just a scientific story but a marketplace for paranoia. And yet, even amid the fear, there was fascination. People who dreaded its arrival also found themselves drawn to telescopes, to live streams, to news updates. The object embodied humanity's paradoxical relationship with the unknown. We fear it, and yet we cannot look away. We imagine the worst, but we also hope for the extraordinary. And so the visitor became a kind of collective mirror, reflecting back both our nightmares and our dreams. It reminded us of our vulnerability, but also of our capacity to wonder, to imagine, to grapple with mysteries larger than ourselves. Some cultural critics argued that the doomsday obsession was a symptom of deeper anxieties. In a world already burdened by climate change, pandemics and political instability, the visitor became a vessel for all our fears. It was easier to project dread onto a rock from another star than to face the slow-motion disasters of our own making. The idea of an instant, fiery end was almost comforting compared to the drawn-out uncertainties of modern life. It was fear, yes, but it was also release. A cosmic reset button that many secretly longed for, even as they prayed it would never come. As the weeks passed and the object grew fainter, the panic began to ease. People saw that Earth remained intact, that the fiery apocalypse never came. But the echoes of fear lingered. For many, the visitor had opened a door in the imagination that could not be closed. If one city-sized rock from another system could pass so close, then surely others would follow. And next time, perhaps, we would not be so lucky. The fears eventually gave way to other headlines, but the memory of them endured. In classrooms, children still asked teachers if the visitor could come back. In churches, sermons still referenced it as a warning. In survivalist communities, it remained a rallying cry, proof that humanity must always be ready for catastrophe. The doomsday speculation had burned bright, and though the fire dimmed, the embers stayed hot. The visitor had not destroyed us, but it had reminded us of the thinness of the veil that separates safety from extinction. And so, as it vanished into the dark, the world carried forward two truths: that we had nothing to fear from this particular traveller, and that the universe still holds countless others whose paths we cannot predict. Fear was not misplaced, it was simply premature. When the panic and speculation began to subside, something quieter but no less powerful emerged. Beyond the headlines and the doomsday chatter, people began to reflect on what it meant to live in a universe where such a visitor could appear at all. Philosophers, poets, theologians, and ordinary observers alike started to speak of the object not as a harbinger of destruction, but as a symbol. It was no longer just a city-sized comet or asteroid from another system. It was a mirror held up to humanity, a reminder that our story is woven into something much larger, something far older and more mysterious than the boundaries of our own sky. For many, the visitor became a metaphor for connection. Here was matter that had been forged around a star that might now be dead, drifting across the galaxy for millions of years, only to appear briefly in our solar system, just long enough for us to notice it. In that sense, it was a kind of cosmic handshake, proof that the boundaries between systems are not impermeable. Dust from distant worlds mingles with ours. Chemistry is not confined to Earth, or even to our sun's family. We are part of a galactic web, strands of matter and energy tying us to places we will never see. To study the visitor was to study ourselves in a different light, to realize that the universe is not foreign but shared. This line of thought found fertile ground in philosophy. Thinkers compared the object to the ancient role of comets in human history. For millennia, people looked at streaks across the sky and saw omens of war, of famine, of the fall of kings. Those beliefs were rooted in fear, but also in awe. Comets were reminders that the heavens were not static, that change could come suddenly from above. Now, in the modern era, we knew more. We could calculate trajectories and measure isotopes, but the emotional resonance was the same. The visitor carried forward that ancient tradition of forcing us to look up and wonder what it meant. Not an omen, perhaps, but a messenger nonetheless, one that whispered about our place in a cosmos alive with motion. Religious leaders also found meaning in its presence. Some framed it as evidence of divine creation, proof that the universe is richer and more abundant than we can fathom. Others saw it as a test of humility, a reminder that humanity is small and fragile in a creation that stretches far beyond comprehension. Sermons and writings used the visitor as a starting point for reflections on stewardship of Earth, on gratitude for existence, and on the possibility that life in some form might be scattered across the stars. For people of faith, it became a vessel for hope rather than fear, a sign that we are not forgotten in the vastness of creation. Artists, too, embraced the symbolism. Painters depicted it not as a rock, but as a glowing lantern drifting through night skies, a beacon for lost civilizations. Poets compared it to a traveler carrying messages written in a language of light and dust. Musicians composed symphonies and ambient pieces, meant to capture the slow, steady pulse of its journey. In their hands, the visitor ceased to be a cold object and became instead a character, a wanderer, a witness, a silent teacher passing through. The arts gave form to feelings the sciences could not measure: awe, longing, a sense of kinship with the unknown. Even scientists found themselves caught in the tide of meaning. Though they dealt in data, many admitted privately that studying the object felt different from ordinary research. To read its chemistry was to touch something born in another world. To measure its orbit was to trace the path of a journey spanning millions of years. The numbers were precise, the instruments objective, but behind every calculation lurked an almost spiritual weight. For once, the cosmos was not something abstract, distant or theoretical. It was here, rushing past, tangible enough to be seen with backyard telescopes, generous enough to share its secrets before slipping away forever. The object also sparked conversations about destiny. Some thinkers argued that its passage was a reminder of what humanity must one day become. If chunks of rock and ice could cross the gulfs between stars, then so too could civilizations. The visitor was not just a relic of another system, it was a preview of our own future, a demonstration that interstellar travel is possible, even if only by accident. To them, the message was clear: the stars are not unreachable, they are waiting. The visitor's trajectory, hyperbolic and unbound, became a metaphor for human aspiration to escape the gravity of our limitations and become wanderers ourselves. Others took a different approach, seeing the visitor as a symbol of mortality. Its brief appearance in our skies mirrored our own fleeting existence. It reminded us that even great enduring things are temporary. Just as it had entered and would soon leave our system, so too do we enter and leave the stage of life, our presence short against the backdrop of eternity. Some found this thought melancholy, others liberating. If life is brief, then it must be cherished. If civilizations are fragile, then their time must be used wisely. The visitor in its silence offered a kind of wisdom without words, that impermanence is the rule of the cosmos, and meaning comes not from duration but from present. The symbolism extended into politics and culture. Leaders invoked the visitor in speeches, drawing parallels between the unity required to study it and the unity needed to address earthly challenges. Commentators described it as a reminder that borders mean little when measured against the scale of space, that humanity is one species sharing one fragile planet. The object became a rhetorical tool, a cosmic metaphor for cooperation in an age of division. Some dismissed this as opportunistic, but others saw value in the reminder. When faced with something so vast and indifferent, perhaps it is natural to look inward and realize that our quarrels are small by comparison. What made the symbolism so potent was its ambiguity. The visitor was, in truth, nothing more than a rock and ice giant hurled from another system. But because it carried no message of its own, we could project onto it whatever meaning we needed. For some, it was a threat, a reminder of extinction. For others, it was hope, proof of connection. For still others, it was destiny, a beacon pointing us toward the stars. Its silence was its power, a canvas broad enough to hold every interpretation. As it grew fainter, slipping beyond the reach of amateur telescopes, the symbolic weight only deepened. Now it was less an object to observe and more a story to remember, a myth in the making. Children who had seen it through backyard lenses would tell their grandchildren that they had watched a visitor from another star pass by. Artists would continue to paint it, philosophers to ponder it, scientists to analyze its data. Its presence would linger long after its light had vanished, not because of what it was, but because of what it had meant. And perhaps that was its greatest gift. Not the data, though the data was precious. Not the chemistry, though the chemistry was remarkable. Not even the awe, though the awe was undeniable. Its greatest gift was meaning. It forced humanity to ask questions about connection, destiny, mortality, and unity. It reminded us that the cosmos is not empty, that our story is part of a greater one, and that sometimes the universe speaks not in words but in the silent passage of a glowing wanderer across the sky. By the time the visitor had slipped beyond the reach of most telescopes, it had already left something irreversible in its wake. The world had watched, wondered, feared, and dreamed. But in the halls of governments and space agencies, a different kind of conversation had begun. One not about symbolism or speculation, but about preparation. The visitor had been generous, large enough to study, bright enough to track, harmless enough to pass us by. But what about the next one? What if the next traveler was smaller, harder to detect, and aimed directly at Earth? What if the chemistry we glimpsed was only a hint of the possibilities, and we missed the chance to study it because we lacked the tools? What if one day, instead of a silent rock, we faced something intentional? These questions lingered long after the object was gone, and for the first time in decades they began to shape concrete plans. Inside NASA, the European Space Agency, and their counterparts around the globe, committees convened to assess the lessons learned. Reports circulated that highlighted both triumphs and failures. The triumphs were obvious: collaboration across borders, unprecedented data sharing, rapid adaptation of telescopes to track an object never before seen. But the failures were glaring too. We had been caught off guard yet again. No rapid response mission was ready. No spacecraft could intercept it. No samples could be taken. We had watched from a distance, powerless to do more than collect photons. The frustration was palpable. We could send rovers to Mars, probes to Jupiter, even spacecraft beyond the edge of the solar system. Yet when something from another star system passed right through our own backyard, all we could do was look. The urgency sparked a flurry of proposals. Some advocated for dedicated sky survey telescopes built specifically to catch faint, fast-moving objects long before they reached the inner solar system. These surveys already existed in part, but their funding was limited, their coverage incomplete. To detect the next interstellar visitor with enough time to act, humanity needed something bigger, broader, more vigilant. Others argued for spacecraft designed not for long-term exploration, but for rapid launch. Missions like NASA's Comet Interceptor, planned to wait in space until a target appeared, suddenly seemed prophetic. If humanity had had one ready during this encounter, we could have flown alongside the visitor, snapped close-up images, maybe even sampled its dust. The regret was sharp, but so too was the resolve. Next time we must be ready. The discussions didn't stop at science. Planetary defense groups seized on the moment to emphasize the danger such objects could pose. Yes, this visitor had missed us. But what if it hadn't? A city-sized body traveling at 36 miles per second was beyond catastrophic. It was extinction itself. Even the asteroid that killed the dinosaurs had been smaller, slower. If the galaxy truly held countless interstellar wanderers, then one day, whether in 1,000 years or 1,000,000, one might be on a collision course with Earth. And unlike ordinary asteroids, which we might divert with enough warning, an interstellar rock moving this fast would give us little time to react. That terrifying thought lent urgency to long-discussed but underfunded ideas: kinetic impactors, nuclear deflection, even ambitious concepts of laser arrays or gravitational tractors. For the first time, talk of planetary defense wasn't dismissed as science fiction. The visitor had made the stakes real. Politicians, sensing the public fascination and fear, found themselves under pressure to act. Hearings were held, budgets were debated. Some leaders framed preparation as an insurance policy, likening it to fire departments or hospital services you hope never to need, but cannot live without. Others saw opportunity in the prestige of interstellar exploration, a chance to claim leadership in a new era of cosmic engagement. In both cases, the result was the same: momentum. Funding increased. International coalitions began to form. The visitor had not only inspired awe in citizens, but had pushed governments into cooperation they might have otherwise resisted. Still, the challenges were immense. Building telescopes capable of catching such objects early required years of development and billions of dollars. Designing spacecraft that could be launched at short notice demanded new technologies in propulsion, fuel storage and mission planning. Coordinating planetary defense across nations that rarely trusted each other was a political minefield. And yet, the visitor's passage had created a rare alignment of urgency and will. Failure to prepare now would mean explaining to future generations why we ignored the warning when it was so clearly delivered. Beyond defense, there was also the lure of discovery. Scientists argued that intercepting an interstellar visitor would not only protect us but transform our understanding of the galaxy. Each one carried chemistry, structure, and history from worlds we could not otherwise touch. To collect samples from their dust, to fly close enough to map their surfaces, to perhaps even land and drill into their cores, these were dreams that now seemed achievable, if only the right missions could be built in time. The visitor had shown that interstellar material was not unreachable. It came to us, all we had to do was be ready to meet it. Meanwhile, private space companies saw opportunity as well. Entrepreneurs pitched ideas for rapid response fleets, small spacecraft mass-produced and stored in orbit, ready to launch at a moment's notice. Some spoke of mining the resources of interstellar rocks, envisioning wealth beyond imagining in the metals and ices carried across light years. Others framed it more romantically, a chance for humanity's first true contact with the galaxy beyond. Whether motivated by profit or passion, the private sector's interest ensured that preparation wouldn't rest on governments alone. A new industry, interstellar engagement, was quietly being born. And yet, alongside the optimism ran a thread of unease. Because preparation implied expectation, to build fleets and defenses was to admit that more visitors would come, some perhaps not so harmless. It meant accepting that the galaxy is not a distant backdrop but an active environment in which our planet is vulnerable. That realization unsettled many. For centuries we had imagined Earth as an isolated haven, shielded by vastness. The visitor had shattered that illusion. We were part of the traffic of the stars, exposed to its gifts and its dangers alike, and now we faced a choice: hide from it or embrace it. In the months after the visitor vanished into the dark, that choice played out in debates across the globe. Some voices called for retreat, for focusing inward, for avoiding the temptations of space. Why spend billions chasing rocks when poverty, disease, and conflict ravaged Earth? Others countered that preparation was not indulgence but survival, that ignoring the cosmos was as reckless as ignoring a storm on the horizon. The arguments grew fierce, but beneath them all was the undeniable fact: the visitor had already changed us. We could no longer claim ignorance. We had seen what was out there. We had been reminded that the universe does not revolve around us, and once that truth is known, it cannot be unlearned. So governments drafted plans, agencies restructured priorities, international summits included, alongside discussions of climate and trade, sessions on planetary defense and interstellar study. It was messy, imperfect, often mired in politics. But it was also real. For the first time in human history, our species was beginning to think of itself not just as inhabitants of Earth, but as participants in a larger galactic drama. The visitor had passed, but its shadow lingered in boardrooms, in laboratories, in the quiet calculations of mission planners, sketching designs for spacecraft that might one day chase another traveler into the void. And so, long after the object itself had disappeared beyond the reach of even our most powerful instruments, its legacy endured, not in dust or light, but in plans and policies, in dreams and defenses. It had reminded us of our vulnerability, but also of our potential. It had shown us that the galaxy is not empty, that our place within it demands vigilance, curiosity, and courage. And whether we were ready or not, the message was clear: the next visitor will come. The question is, will we be prepared to meet it? When the panic and speculation began to subside, something quieter but no less powerful emerged. Beyond the headlines and the doomsday chatter, people began to reflect on what it meant to live in a universe where such a visitor could appear at all. Philosophers, poets, theologians, and ordinary observers alike started to speak of the object, not as a harbinger of destruction, but as a symbol. It was no longer just a city-sized comet or asteroid from another system. It was a mirror held up to humanity, a reminder that our story is woven into something much larger, something far older and more mysterious than the boundaries of our own sky. For many, the visitor became a metaphor for connection. Here was matter that had been forged around a star that might now be dead, drifting across the galaxy for millions of years, only to appear briefly in our solar system, just long enough for us to notice it. In that sense, It was a kind of cosmic handshake, proof that the boundaries between systems are not impermeable. Dust from distant worlds mingles with ours. Chemistry is not confined to Earth, or even to our sun's family. We are part of a galactic web, strands of matter and energy tying us to places we will never see. To study the visitor was to study ourselves in a different light, to realize that the universe is not foreign but shared. This line of thought found fertile ground in philosophy. Thinkers compared the object to the ancient role of comets in human history. For millennia, people looked at streaks across the sky and saw omens of war, of famine, of the fall of kings. Those beliefs were rooted in fear, but also in awe. Comets were reminders that the heavens were not static, that change could come suddenly from above. Now, in the modern era, we knew more. We could calculate trajectories and measure isotopes. But the emotional resonance was the same. The visitor carried forward that ancient tradition of forcing us to look up and wonder what it meant. Not an omen, perhaps, but a messenger nonetheless, one that whispered about our place in a cosmos alive with motion. Religious leaders also found meaning in its presence. Some framed it as evidence of divine creation, proof that the universe is richer and more abundant than we can fathom. Others saw it as a test of humility, a reminder that humanity is small and fragile in creation that stretches far beyond comprehension. Sermons and writings used the visitor as a starting point for reflections on stewardship of Earth, on gratitude for existence, and on the possibility that life in some form might be scattered across the stars. For people of faith, it became a vessel for hope rather than fear, a sign that we are not forgotten in the vastness of creation. Artists, too, embraced the symbolism. Painters depicted it, not as a rock but as a glowing lantern drifting through night skies, a beacon for lost civilizations. Poets compared it to a traveler carrying messages written in a language of light and dust. Musicians composed symphonies and ambient pieces meant to capture the slow, steady pulse of its journey. In their hands, the visitor ceased to be a cold object and became instead a character, a wanderer, a witness, a silent teacher passing through. The arts gave form to feelings the sciences could not measure: awe, longing, a sense of kinship with the unknown. Even scientists found themselves caught in the tide of meaning. Though they dealt in data, many admitted privately that studying the object felt different from ordinary research. To read its chemistry was to touch something born in another world, to measure its orbit was to trace the path of a journey spanning millions of years. The numbers were precise, the instruments objective, but behind every calculation lurked an almost spiritual weight. For once, the cosmos was not something abstract, distant or theoretical. It was here, rushing past, tangible enough to be seen with backyard telescopes, generous enough to share its secrets before slipping away forever. The object also sparked conversations about destiny. Some thinkers argued that its passage was a reminder of what humanity must one day become. If chunks of rock and ice could cross the gulfs between stars, then so too could civilization. The visitor was not just a relic of another system, it was a preview of our own future, a demonstration that interstellar travel is possible, even if only by accident. To them, the message was clear: the stars are not unreachable, they are waiting. The visitor's trajectory, hyperbolic and unbound, became a metaphor for human aspiration to escape the gravity of our limitations and become wanderers ourselves. Others took a different approach, seeing the visitor as a symbol of mortality. Its brief appearance in our skies mirrored our own fleeting existence. It reminded us that even great, enduring things are temporary. Just as it had entered and would soon leave our system, so too do we enter and leave the stage of life, our presence short against the backdrop of eternity. Some found this thought melancholy, others liberating. If life is brief, then it must be cherished. If civilizations are fragile, then their time must be used wisely. The visitor, in its silence, offered a kind of wisdom without words, that impermanence is the rule of the cosmos, and meaning comes not from duration but from present. The symbolism extended into politics and culture. Leaders invoked the visitor in speeches, drawing parallels between the unity required to study it and the unity needed to address earthly challenges. Commentators described it as a reminder that borders mean little when measured against the scale of space, that humanity is one species sharing one fragile planet. The object became a rhetorical tool, a cosmic metaphor for cooperation in an age of division. Some dismissed this as opportunistic, but others saw value in the reminder. When faced with something so vast and indifferent, Perhaps it is natural to look inward and realize that our quarrels are small by comparison. What made the symbolism so potent was its ambiguity. The visitor was in truth nothing more than a rock and ice giant hurled from another system, but because it carried no message of its own, we could project onto it whatever meaning we needed. For some, it was a threat, a reminder of extinction. For others, it was hope, proof of connection. For still others, it was destiny, a beacon pointing us toward the stars. Its silence was its power, a canvas broad enough to hold every interpretation. As it grew fainter, slipping beyond the reach of amateur telescopes, the symbolic weight only deepened. Now it was less an object to observe and more a story to remember, a myth in the making. Children who had seen it through backyard lenses would tell their grandchildren that they had watched a visitor from another star pass by. Artists would continue to paint it, philosophers to ponder it, scientists to analyze its data. Its presence would linger long after its light had vanished, not because of what it was, but because of what it had meant. And perhaps that was its greatest gift. Not the data, though the data was precious. Not the chemistry, though the chemistry was remarkable. Not even the awe, though the awe was undeniable. Its greatest gift was meaning. It forced humanity to ask questions about connection, destiny, mortality, and unity. It reminded us that the cosmos is not empty, that our story is part of a greater one, and that sometimes the universe speaks not in words but in the silent passage of a glowing wanderer across the sky, but in the halls of governments and space agencies. A different kind of conversation had begun, one not about symbolism or speculation, but about preparation. The visitor had been generous, large enough to study, bright enough to track, harmless enough to pass us by. But what about the next one? What if the next traveler was smaller, harder to detect, and aimed directly at Earth? What if the chemistry we glimpsed was only a hint of the possibilities, and I missed the chance to study it because we lacked the tools? What if one day, instead of a silent rock, we faced something intentional? These questions lingered long after the object was gone, and for the first time in decades they began to shape concrete plans. Inside NASA, the European Space Agency, and their counterparts around the globe, committees convened to assess the lessons learned. Reports circulated that highlighted both triumphs and failures. The triumphs were obvious: collaboration across borders, unprecedented data sharing, rapid adaptation of telescopes to track an object never before seen. But the failures were glaring too. We had been caught off guard, yet again. No rapid response mission was ready, no spacecraft could intercept it, no samples could be taken. We had watched from a distance, powerless to do more than collect photons. The frustration was palpable. We could send rovers to Mars, probes to Jupiter, even spacecraft beyond the edge of the solar system. Yet when something from another star system passed right through our own backyard, all we could do was look. The urgency sparked a flurry of proposals. Some advocated for dedicated sky survey telescopes built specifically to catch faint, fast-moving objects long before they reached the inner solar system. These surveys already existed in part, but their funding was limited, their coverage incomplete. To detect the next interstellar visitor with enough time to act, humanity needed something bigger, broader, more vigilant. Others argued for spacecraft designed not for long-term exploration, but for rapid launch. Missions like NASA's Comet Interceptor, planned to wait in space until a target appeared, suddenly seemed prophetic. If humanity had had one ready during this encounter, we could have flown alongside the visitor, snapped close-up images, maybe even sampled its dust. The regret was sharp, but so too was the resolve. Next time, we must be ready. The discussions didn't stop at science. Planetary defense groups seized on the moment to emphasize the danger such objects could pose. Yes, this visitor had missed us, but what if it hadn't? A city-sized body traveling at 36 miles per second was beyond catastrophic. It was extinction itself. Even the asteroid that killed the dinosaurs had been smaller, slower. If the galaxy truly held countless interstellar wanderers, then one day, whether in 1,000 years or 1,000,000, one might be on a collision course with Earth. And unlike ordinary asteroids, which we might divert with enough warning, an interstellar rock moving this fast would give us little time to react. That terrifying thought lent urgency to long-discussed, but underfunded ideas: kinetic impactors, nuclear deflection, even ambitious concepts of laser arrays or gravitational tractors. For the first time, talk of planetary defense wasn't dismissed as science fiction. The visitor had made the stakes real. Politicians, sensing the public fascination and fear, found themselves under pressure to act. Hearings were held, budgets were debated. Some leaders framed preparation as an insurance policy, likening it to fire departments or hospital services you hope never to need, but cannot live without. Others saw opportunity in the prestige of interstellar exploration, a chance to claim leadership in a new era of cosmic engagement. In both cases, the result was the same: momentum. Funding increased. International coalitions began to form. The visitor had not only inspired awe in citizens, but had pushed governments into cooperation they might have otherwise resisted. Still, the challenges were immense. Building telescopes capable of catching such objects early required years of development and billions of dollars. Designing spacecraft that could be launched at short notice demanded new technologies in propulsion, fuel storage, and mission planning. Coordinating planetary defense across nations that rarely trusted each other was a political minefield. And yet, the visitor's passage had created a rare alignment of urgency and will. Failure to prepare now would mean explaining to future generations why we ignored the warning when it was so clearly delivered. Beyond defense, there was also the lure of discovery. Scientists argued that intercepting an interstellar visitor would not only protect us, but transform our understanding of the galaxy. Each one carried chemistry, structure, and history from worlds we could not otherwise touch. To collect samples from their dust, to fly close enough to map their surfaces, to perhaps even land and drill into their cores. These were dreams that now seemed achievable, if only the right missions could be built in time. The visitor had shown that interstellar material was not unreachable. It came to us. All we had to do was be ready to meet it. Meanwhile, private space companies saw opportunity as well. Entrepreneurs pitched ideas for rapid response fleets, small spacecraft mass-produced and stored in orbit, ready to launch at a moment's notice. Some spoke of mining the resources of interstellar rocks, envisioning wealth beyond imagining in the metals and ices carried across light years. Others framed it more romantically, a chance for humanity's first true contact with the galaxy beyond. Whether motivated by profit or passion, the private sector's interest ensured that preparation wouldn't rest on governments alone. A new industry, interstellar engagement, was quietly being born. And yet, alongside the optimism ran a thread of unease. Because preparation implied expectation. To build fleets and defenses was to admit that more visitors would come, some perhaps not so harmless. It meant accepting that the galaxy is not a distant backdrop, but an active environment in which our planet is vulnerable. That realization unsettled many. For centuries we had imagined Earth as an isolated haven, shielded by vastness. The visitor had shattered that illusion. We were part of the traffic of the stars, exposed to its gifts and its dangers alike. And now we faced a choice: hide from it or embrace. In the months after the visitor vanished into the dark, that choice played out in debates across the globe. Some voices called for retreat, for focusing inward, for avoiding the temptations of space. Why spend billions chasing rocks when poverty, disease, and conflict ravaged Earth? Others countered that preparation was not indulgence but survival, that ignoring the cosmos was as reckless as ignoring a storm on the horizon. The arguments grew fierce, but beneath them all was the undeniable fact: the visitor had already changed us. We could no longer claim ignorance. We had seen what was out there. We had been reminded that the universe does not revolve around us. And once that truth is known, it cannot be unlearned. So governments drafted plans. Agencies restructured priorities. International summits included, alongside discussions of climate and trade, sessions on planetary defense and interstellar study. It was messy, imperfect, often mired in politics. But it was also real. For the first time in human history, our species was beginning to think of itself, not just as inhabitants of Earth, but as participants in a larger galactic drama. The visitor had passed, but its shadow lingered in boardrooms, in laboratories, in the quiet calculations of mission planners sketching designs for spacecraft that might one day chase another traveler into the void. And so, long after the object itself had disappeared beyond the reach of even our most powerful instruments, its legacy endured, not in dust or light, but in plans and policies, in dreams and defenses. It had reminded us of our vulnerability, but also of our potential. It had shown us that the galaxy is not empty, that our place within it demands vigilance, curiosity, and courage. And whether we were ready or not, the message was clear: the next visitor will come. The question is, will we be prepared to meet? By the time the visitor finally slipped from our skies, fading into the blackness where even the most powerful instruments could no longer follow. Its journey through our awareness was complete. The object itself was indifferent, a silent traveler continuing its path into the void. But its passage through human consciousness had been anything but silent. It had stirred debates, ignited fears, inspired art, and forced governments to prepare for futures they had long ignored. And then, as it receded into the unseeable, it left behind something that could not be measured by telescopes or spectrographs, a lingering presence in our imagination, a shadow we could feel even after the light was gone. For months after its disappearance, newspapers and networks occasionally published updates, though there was little left to say. Scientists continued to pore over the terabytes of data, trying to resolve inconsistencies in the spectra, attempting to model its shape, simulating trajectories backward to guess at its origin. None of these efforts offered definitive answers. The chemistry could be explained as unusual but not impossible. The orbit could be reconciled with natural dynamics. The outgassing, the reflectivity, the speed, every anomaly had potential explanations. Yet no single theory fit them all. The object retained its mystery, a puzzle that refused to settle neatly into any box. For scientists, this was both frustrating and thrilling. For the public, it was maddening. People wanted closure, a final word, a headline that declared once and for all what it had been. But closure never came. The visitor remained, in the end, what it had always been, a stranger glimpsed in passing, never truly known. This lack of resolution became part of its myth. Just as ancient comets left stories in their wake, this modern traveler left uncertainty, and in that uncertainty humanity did what it has always done. We told stories. Some believed it had been a probe, a machine so advanced we could not recognize it. Others held to the idea of a natural wanderer, a shard of some ancient collision that had traveled for millions of years before brushing past our star. For many it became both things at once, natural in origin, but perhaps carrying within it the seeds of knowledge, the chance to teach us humility and curiosity in equal measure. In equal measure. Its silence was not emptiness, but invitation. Philosophers argued that the visitor's greatest impact was not the data, but the perspective it forced upon us. We had been reminded, vividly and undeniably, that we are not isolated. The galaxy is alive with motion, with objects born in other suns, with stories written in dust and ice that cross from one system to another. In this sense, the visitor was proof of connection, not of aliens, necessarily, but of kinship. The same processes that shaped our Earth had shaped it. The same chemistry that built our oceans lay frozen in its body. To study it was to see ourselves as part of a larger whole, not the center of creation, but one participant in a vast and ongoing narrative. And yet, even with this broader view, there was unease. For if such visitors were possible, then so too were collisions. The visitor had passed us by, harmless, beautiful, generous with its mysteries, but the next might not. That duality, wonder and dread, became inseparable from the story. People could not look at the night sky without remembering that unseen objects might even now be on their way toward us, silent and fast, their trajectories unknown. The visitor had taught us awe, but it had also taught us vigilance. In cultural memory it became something more than a rock. It became a symbol. In novels it was cast as a messenger. In films it was depicted as a harbinger. In poetry it was painted as a ghost, slipping through the dark to remind us of our mortality. Each retelling shifted its meaning, but all agreed on its importance. Humanity had been touched by something vast and fleeting, and though it had vanished, its presence lingered like an afterimage burned into the eye. Governments and agencies kept its memory alive through plans and missions. New telescopes were funded, new defense strategies drafted, new concepts for rapid response probes proposed. The visitor had seeded not only myths but policies, and those policies ensured its influence would extend for decades, perhaps centuries. Generations not yet born would live under systems designed because of this one object, their futures quietly shaped by a rock that passed before they even existed. That was its legacy, not a shirk, not salvation, but preparation. A reminder that we are part of a living cosmos, and that to survive within it we must learn to look outward as much as inward. But perhaps the most haunting legacy was the silence it left behind. As weeks turned to months and months to years, the absence of new visitors gnawed at the imagination. If 3 had been found in such a short span, surely more would come. Each night, telescopes scanned the skies with fresh urgency, and each faint dot sparked excitement before fading into ordinary. The anticipation of another interstellar guest became a kind of hunger, a collective leaning forward into the dark. We had seen what was possible, and now we could not stop waiting for the next. That waiting carried with it a sense of unfinished conversation. The visitor had arrived, revealed itself briefly, and then departed without explanation. It was as though a knock had come at our door. We had glimpsed a stranger in passing, and then the door had closed again, leaving us wondering who they had been, what message they carried, and whether they would return. That sense of interruption of a story half told haunted us, and in that haunting humanity found both discomfort and drive. Years from now, people will still remember where they were when they first heard the headlines. Children who had looked up at the streak of light will grow into adults who tell their own children about the night they saw a visitor from another star. Scientists will still reference its anomalies in papers, artists will still depict its passage in galleries, and philosophers will still use it as a metaphor for impermanence and connection. The visitor will persist, not as an object but as a story, etched into culture in the same way that great events always are, not because of what it was, but because of what it meant. In the end, the visitor was a reminder of two truths. First, that we are fragile, small creatures on a small planet, vulnerable to forces beyond our control, exposed to a cosmos that neither knows nor cares if we exist. And second, that we are capable of wonder, able to see, to imagine, to tell stories, to plan, to prepare, to dream of futures where we meet the unknown, not with fear alone, but with curiosity and courage. Between those truths lies the essence of being human. So the visitor receded into darkness, gone but not forgotten. It carried with it no words, no signals, no clear answers, and yet, in its silence, it spoke volumes. It told us that we are not alone in the flow of the galaxy, that the stars send us gifts and warnings alike, and that to live in this universe is to live with mystery. It left us staring at the night sky with new eyes, wondering not if but when the next traveller will appear, and when it does, we will remember the first, and we will be ready to listen to the silence again. Long after the visitor had vanished into the cold abyss between stars, its presence lingered in ways both subtle and profound. The data sat archived in servers around the world, numbers and graphs that could be pulled up by scientists decades from now. The headlines faded, replaced by fresher crises, yet echoes of the story remained in documentaries, in novels, in classrooms where teachers reminded students that they had lived during a time when a piece of another star system passed so close they could see it with their own eyes. Children grew up sketching it in notebooks, imagining what secrets it carried. Artists painted murals of a luminous traveler streaking across the sky. Musicians composed works inspired by its silence. Even when it was gone, it remained, not as matter but as myth. Epilogues in history often close stories neatly, but this was an ending without closure. Every attempt to explain the anomalies of its behavior only deepened the mystery. Was it a comet, behaving strangely but still natural? Was it a shard of a planet long since shattered? Or was it something more, something crafted, not born? Its silence intentional? None of the answers satisfied completely, and so the object became a paradox preserved in memory, simultaneously explained and unexplained, ordinary and extraordinary. In its ambiguity lay its power, for it reminded us that not everything can be neatly resolved, and that sometimes mystery itself is the gift. For those who had followed its passage closely, the weeks after its disappearance felt like waking from a dream. Each night of its visibility had been a shared ritual, millions of eyes turning upward to watch it inch across the dark, and then suddenly the ritual ended, leaving behind a strange absence. The sky was the same, but not the same. To look up now was to know something had been there, and was no longer. It was like remembering a visitor who had walked through your home, left without a word, and closed the door softly behind them. Nothing was damaged, nothing taken, but the silence afterward felt charged, as though the walls remembered. That charge pushed humanity to new kinds of reflection. For some, the visitor became a reminder of fragility, that no matter our technology or arrogance, we are at the mercy of forces far greater than us. For others, it was a symbol of potential, that we too could one day travel between stars, carrying our own fragments across light years. And for still others, it was a riddle, meant to unsettle us, to shake us from complacency, to force us to admit that we do not yet understand the universe nearly as well as we pretend. Governments codified its legacy in budgets and treaties. Missions were approved, telescopes funded, proposals drafted for spacecraft that could be launched within days of a new discovery. The memory of this visitor became a line item in national security discussions, in scientific roadmaps, in international collaborations. While the public shifted its focus, planners and scientists carried forward the urgency. They knew that the next interstellar object might already be on its way, and if so, this was only the beginning of an age when humanity must learn to meet travelers from beyond, with more than just curiosity. The visitor also redefined how we thought of ourselves. For centuries, we had treated our solar system as our neighborhood, our corner of the galaxy. But its passage forced us to see that the boundaries are porous. Just as meteors carry whispers of Mars or asteroids carry echoes of early Earth, so too can objects carry stories from other suns. We are not isolated. We are nodes in a web of galactic exchange, even if that exchange happens in fragments of ice and stone drifting for eons. This realization transformed not only astronomy, but philosophy. To exist was to be part of a living, moving cosmos, one in which separation was an illusion and connection was the rule. The visitor faded, but it never ended. Each time scientists spoke of preparing for the next one, they invoked its memory. Each time artists painted or poets wrote of stars, they drew upon its imagery. Each time a child asked, could it have been a ship? The story reignited. It was not finished because it was never meant to be finished. It was a chapter in a book, still being written, a spark that promised sequels, and this sense of continuation may have been the most haunting gift of all. The certainty that more visitors will come, each carrying its own mysteries, each forcing us once again to confront our place in the dark. Even decades later, the question lingered. What if it hadn't been random? What if its timing, its trajectory, its very visibility were part of a pattern we had yet to see? Some dismissed this as fanciful, others leaned into it as evidence of meaning, but regardless of belief, the question lingered because the object itself had been real. This wasn't mythology or prophecy. This was an observable fact, recorded by telescopes, analyzed by computers, witnessed by millions. And in that fact lay a rare kind of authority. You could doubt interpretations, but you could not doubt that it had come. Perhaps in the end, the visitor's silence was its most eloquent feature. Had it carried a signal, or revealed itself as a craft, or left behind unambiguous evidence of design, the story would have been one of answers. Instead, it gave us questions, and those questions multiplied, spreading outward like ripples. Why here? Why now? How many others? How long before the next? Each question pointed not only outward to the cosmos, but inward to ourselves. What do we fear? What do we hope? How will we respond when confronted with the unknown again? The silence did not leave us empty. It left us listening. And so the story does not end with the object's departure, but with our own awareness, sharpened, restless, waiting. We scan the skies differently now, not just with instruments but with expectation. We speak of planetary defense not as fantasy but as necessity. We teach children that the stars are not distant scenery but part of our shared environment. We remind ourselves that fragility and wonder are not opposites but companions, two truths that define us as much as any orbit or equation. The visitor left us with no final word, no parting gesture. It simply continued, carrying its secrets back into the deep. But in doing so, it left behind something more valuable than answers. It left us awake. Awake to our vulnerability, awake to our connection, awake to the fact that the universe is not static, not silent, not empty. Awake to the realization that mystery is not a failure, but a gift. We cannot control the stars, but we can choose how we meet them, with fear or with wonder, with denial or with courage. And as the last glimmers of its light faded, humanity understood something that would echo for generations. That we are not the center, not the end, not the sole story of the cosmos. We are one thread in a vast and intricate fabric, and sometimes another thread passes close enough to brush against us, leaving behind a trace of its journey before moving on. That trace, faint but unforgettable, is enough to remind us who we are and who we might become. And perhaps that is the truest legacy of the visitor. Not the data, not the panic, not the speculation, but the reminder that to live in this universe is to live with mystery, and that mystery more than anything else is what makes us human. Even after the visitor had faded into invisibility, its memory refused to fade with it. Time passed, seasons changed, and new headlines replaced the old, But deep in the collective psyche of humanity, that city-sized stranger from another star never truly left. It became part of the cultural atmosphere, like a song whose melody is never forgotten, resurfacing unexpectedly in quiet moments. Astronomers kept its data alive in conferences, citing it in papers and speculating about its mystery. Writers invoked it in essays, weaving its presence into metaphors about impermanence and destiny. Artists continued to depict it as a glowing shard of the unknown, crossing canvases in strokes of light against endless black. It had moved on, yes, but it had also settled into us, embedded not in the sky but in our consciousness. The strange thing about the visitor was that it seemed to grow larger in imagination as it grew smaller in reality. While it was visible, its appearance was humble, a faint dot in a telescope, a dim trace across the heavens. But once it was gone, once the absence took hold, it became monumental. People remembered it not as a speck of light, but as a symbol of cosmic enormity, a reminder that we are part of something we cannot contain. The silence it left behind allowed the mind to magnify it, to turn it into an icon. In that sense, the visitor became more alive in its departure than it ever was in its presence. For scientists, the absence was filled with ambition. The visitor had shown them the limits of their tools, and those limits became challenges to overcome. The push for new telescopes intensified, for sky survey networks capable of spotting the next traveler years before it arrived. Space agencies debated the design of interception missions, and though politics and budgets slowed progress, the spark was undeniable. Every proposal for planetary defense, every blueprint for rapid response spacecraft, carried the ghost of the visitor behind it. The traveler had left no samples for us to study, but it had left the resolve to ensure we would never again be caught so unprepared. Its legacy became the blueprints of futures still unborn. In literature, it became myth. Novels recast it as an emissary, stories imagining civilizations that had sent it across light years to carry messages too subtle for us to decode. Other tales turned it into a test, a cosmic riddle meant to measure our readiness for contact. Poets compared it to a flame passing in darkness, illuminating our fragility with a fleeting glow. Musicians wrote pieces that captured its silence, long movements of quiet crescendos and sudden fading notes, designed to evoke the awe of something appearing suddenly and vanishing forever. Across cultures, the visitor became not just an object, but a character, given qualities of intention and presence, turned into a messenger even if its message was never written. And within everyday life it persisted too. Parents told children bedtime stories of the rock from another sun. Teachers used it as an example of discovery, a way to explain that the universe is not static but alive, full of travelers. Amateur astronomers looked to the skies with fresh hunger, hoping they might be the first to glimpse the next. For people who had seen it themselves, even as a faint dot, there was pride in saying, "I saw the traveler from another world." That memory became a quiet badge of witness, a reminder that they had lived through history, not abstract but personal. But more than anything, the visitor transformed the way humanity thought about its future. For centuries, our dreams of space have been tethered to our own system. The moon, Mars, the outer planets, perhaps one day the Oort cloud. The visitor widened that horizon. It made interstellar space feel less remote, less like a vast ocean and more like a highway on which travelers occasionally passed. If a fragment of another system could find its way here, then the gap between stars was not an unbroken void. It was a space of movement, a space where stories intersected. And if fragments could travel, why not us? To many, the visitor was not only a reminder of what we could not control, but a preview of what we could one day achieve. It was a promise hidden inside a question. If rocks can cross between stars, why not civilization? The thought lingered. Perhaps we had not witnessed an ending, but a beginning. Perhaps the visitor was the first of many, or perhaps it was simply the first we noticed. The more sensitive our telescopes became, the more likely we were to see others, each bringing their own peculiarities, their own riddles. Some would be small, unnoticed except by experts. Others might rival or even surpass this one, blazing across the sky bright enough to awaken wonder in billions. And one day perhaps we might find one close enough, slow enough, accessible enough to intercept, to touch, to hold. The visitor itself was gone, but it had planted the seed of inevitability, that one day we would meet another, and when we did, everything we had dreamed would be tested. In that sense, the visitor's greatest gift was not its data, nor even its symbolism, but its anticipation. It left us leaning forward, watching the skies, waiting for the next. Humanity had always looked upward with curiosity, but now the curiosity was sharpened, directed. It was not just wonder at the stars in general, but expectation of a specific event. Another traveler, another moment when the galaxy reached into our system and left something behind. That anticipation changed us. It made us students of patience, teaching us that discovery is not always about immediacy, but about readiness. It made us humble, reminding us that our story is shaped as much by what arrives unexpectedly as by what we pursue intentionally. And it made us restless, knowing that we had glimpsed possibility and could not go back to indifference. Even as decades pass, the visitor will not fade. Its memory will be stitched into the narrative of humanity's growing awareness of its cosmic context. Just as the discovery of other planets reshaped our sense of place, just as the sight of Earth from space reshaped our sense of unity, so too did the visitor reshape our sense of connection to the galaxy. We will continue to write about it, argue about it, reinterpret it, because that is what we do when confronted with something larger than ourselves. We weave it into our identity, making it part of who we are. And in that way, the visitor will remain long after its atoms have drifted into oblivion, long after Earth itself is gone. The visitor was never ours to keep. It passed through briefly, indifferent, continuing a journey that had begun millions of years before, and would continue millions after. But in the brief moment when its path crossed ours, it left us with questions that may never be answered. And that perhaps is the point. Answers end stories. Questions carry them forward, and the visitor's story is not ended, but carried, alive in the way it changed us, alive in the way it sharpened our eyes, alive in the way it made us lean forward into the dark and ask, with both fear and wonder, who else travels the galaxy's roads? And so, in the stillness of its absence, we continue to listen. We listen not for sound, but for silence. We watch not for certainty, but for possibility. We live with the knowledge that the universe is not empty, that travelers exist, that one day another will come, and when it does, we will remember the first, and we will know that this was never the end, but only the beginning of a conversation written in starlight, silence, and the fleeting passage of a stranger from another world. The visitor was gone, and yet the story did not end with its fading light. If anything, its departure marked the beginning of a longer, quieter tale, one not written in telescopes or headlines, but in the deep corridors of memory and imagination. We had looked up, seen something alien to our system, and watched it pass us by, and though it left us with no message, no signal, no undeniable proof of anything beyond itself, the silence it carried was louder than any proclamation. It reminded us that we live in a galaxy alive with motion, and that our planet, so seemingly isolated, is not immune to encounters from beyond. It reminded us of fragility, of potential, of the vast space between certainty and mystery. And in that reminder, it gave us something that will outlast the object itself. Perspective. Perspective is a strange inheritance. It changes how we view not only the cosmos but ourselves. Before the visitor, interstellar objects were curiosities, rare enough to ignore, too abstract for public imagination. Afterward, they became real, tangible, undeniable. People who had never cared for astronomy suddenly understood that the stars are not distant paintings hung on the black wall of night. They are engines of creation, casting fragments into space that sometimes find their way to us. We are not separate from them. We are woven into the same fabric, touched by the same forces, connected by the same currents that carry travelers across the gulf. That awareness lingers, reshaping how we think about our origins and our destiny. The visitor's path itself became a kind of metaphor. It came from the dark, appeared suddenly, travelled briefly across our skies, and then slipped away again into obscurity. In its motion, people saw reflections of their own lives, brief flashes of presence in an endless flow of time. Just as the object was unbound by our sun, so too are we unbound by permanence. Our lives are arcs, not circles, moments that cross and then fade. For some this thought was unsettling, a reminder of mortality. For others it was liberating, a call to live brightly in the moments we have. The visitor's story became not only cosmic but personal, a mirror for the brevity of existence and the beauty that can still be found in passing. Scientists continued to debate its anomalies. Was its acceleration purely natural? Were its reflective surfaces evidence of some exotic composition? Did its chemistry reveal clues about distant solar systems? These questions remained, and likely always will. But the deeper legacy of the visitor was not in the details, but in the change it inspired. Funding flowed to new missions. Telescopes were built with sharper eyes and wider nets. The next traveler, when it comes, will not find us as unprepared. Spacecraft will wait in orbit, ready to launch at a moment's notice. Instruments will be tuned, networks connected, global collaborations rehearsed. The visitor taught us humility, but it also taught us resolve. We may not have intercepted this one, but we will be ready for the next. In this way, the stranger from another star became not just a reminder of fragility, but a catalyst for resilience. Beyond the laboratories and agencies, the visitor reshaped culture itself. It became a symbol in art, literature, and faith, interpreted through countless lenses. Some painted it as a messenger of destiny, others as a harbinger of doom, others still as a simple wanderer, carrying no intention but its own existence. Its ambiguity was its strength. It allowed every culture, every individual to see in it what they needed most. For some, it was hope that the universe is alive with stories beyond our own. For others, it was a warning of forces indifferent to us. For still others, it was a challenge to embrace mystery not as failure, but as invitation. In this way, the visitor lived on not as one truth but as many, each shaped by the hands of those who remembered it. And so humanity carried forward not only the science but the myth. In classrooms, teachers spoke of it as the great traveler, proof that we share the galaxy with fragments of other worlds. In stories, it became a character, drifting silently between stars, arriving without warning, reminding civilizations of their place in the cosmos. In music, it was silence and crescendo, the echo of something both fleeting and infinite. In all these forms, it became more than itself. It became a symbol of the unknown, and of our capacity to seek meaning within it. There was, too, a deeper unease that never entirely faded, for if one such visitor could arrive harmlessly, another might not. The thought haunted scientists and laypeople alike, that somewhere in the dark, a larger, faster, more dangerous body might be hurtling unseen toward us. The visitor had passed us by, generous in its harmlessness, but it left behind the certainty that Earth's history is fragile, that extinction has come before and could come again. This unease was not panic, but vigilance, a quiet understanding that planetary defense is not science fiction but survival. The visitor forced us to accept that the universe will not bend to our comfort. We must be ready to adapt, to prepare, to meet the next traveler not only with awe but with strategy. Yet even with that unease, awe remained dominant. To know that we had witnessed a fragment of another sun system, a body older than our species, traveling freely through space and appearing briefly within our reach, was to feel connected to something infinite. It was to feel both small and vast at once. Small because of our fragility, vast because of our awareness. No other species on Earth looked up at that visitor and asked what it meant. No other species debated whether it was natural or intentional, painted it into art, or prepared spacecraft to meet its successors. That ability to imagine, to question, to wonder, that was our gift, and the visitor reminded us of it. Time will pass, and the visitor will recede not only from sight, but from memory. Future generations may learn of it only in history books or archived videos. But even then, its legacy will live in the telescopes scanning the skies, in the spacecraft waiting for their missions, in the cultural artifacts it inspired, in the philosophies it shaped. Its presence will persist, invisibly, woven into the structures we built in response. It will remain not as an object but as an influence, a ghost carried forward in the way we think, plan, and dream. And perhaps one day, when another visitor arrives, brighter, closer, undeniable, the memory of the first will return in full force. People will look up again, and they will remember that once, long ago, a stranger passed by and changed us without ever meaning to. They will remember that we leaned forward into the dark, that we asked questions without answers, that we prepared for the next. And in that remembering, the story will continue, one traveler linking to another, one mystery leading to the next. In the end, the visitor was not just a rock from beyond. It was a reminder of what it means to be human, to wonder, to fear, to prepare, to dream. It reminded us that our place in the cosmos is neither central nor irrelevant, but but participatory, woven into currents far larger than ourselves. It reminded us that silence can speak, that absence can linger, that questions can be more powerful than answers. It reminded us that the universe is alive with motion, and that sometimes, if we are watching, it lets us glimpse the travelers who pass by. And so, though it is gone, the story is not finished. The visitor continues in us, in our questions, in our vigilance, in our... It will live as long as we remember to look up at the night sky and wonder who else is out there, what else drifts across the dark, and when we will next hear the quiet knock of a stranger passing by. The sky is vast, the road long, and we are only beginning to understand it. But when the next visitor comes, and it will, we will be ready to listen to its silence, to measure its secrets, to carry forward the story that began with the first. And perhaps when our own descendants become the travelers, crossing between stars, they will remember that once long ago, another traveler passed us by and taught us to dream of journeys without end. The visitor is gone now, lost to the dark beyond our sight, but its presence lingers like a whisper at the edge of memory. For a brief moment, it was ours, not to own, not to capture, but to witness. A stranger from another star, traveling for millions of years, arrived without warning, crossed our skies and vanished again into silence. It left no message, no signal, no proof of purpose. And yet, in its passing, it spoke volumes. It reminded us of our fragility, of the impermanence of our existence, of the vastness of the stage upon which our small lives unfold. At the same time, it reminded us of our gift, the capacity to notice, to ask, to wonder. No other species looked up at that faint dot and thought about origins, destiny, or connection. We did. That is what makes us human. The visitor carried no answers, only questions, and perhaps that is its greatest legacy. Answers close doors, but questions open them. Each anomaly, each unexplained detail left us restless, eager, unsatisfied. Was it natural? Was it intentional? Was it merely a shard of another system, or a machine built by minds we cannot imagine? We may never know. But the silence it left behind was not emptiness. It was invitation. Invitation to build better instruments, to prepare for the next, to widen our gaze, to expand our imagination. The object itself may be gone, but the anticipation it sparked continues. Somewhere out there, another traveler is already on its way, and when it comes, we will meet it differently, because of this one. Its story was never about what it was, but about what it meant. To some, it was a warning that extinction lurks in the indifference of the cosmos. To others, it was hope that the galaxy is alive with motion and connection. To others still, it was destiny, a preview of the journeys humanity might one day take between the stars. Each interpretation was true in its own way, because the visitor was not a fact alone, it was a mirror. We looked at it and saw ourselves, our fears, our hopes, our longing for meaning. That is why it mattered. That is why it will be remembered. In its departure, the visitor gave us perspective. We are not isolated. We are not central. We are threads in a web too vast to comprehend, connected to other suns, other systems, other worlds by currents of matter and motion that stretch across light years. To live with that awareness is to live humbly, but also to live expansively. It is to know that the universe is not empty, that surprises can arrive at any moment, and that our story is part of something larger than we can ever write alone. And so, the conclusion is not an ending but a beginning. The visitor's light has faded, but the questions it left remain bright. We will continue to watch, to prepare, to dream. We will continue to tell its story, not because it gave us certainty, but because it gave us wonder. And when the next traveler comes, and it will, we will remember this one. The first that made us pause, the first that made us listen to the silence, the first that taught us that sometimes the greatest message is not in what is said, but in what is left unsaid. The universe is alive with mysteries, and as long as we are here to look up, we will never stop chasing them.